Hello and welcome to this Python course. In this full course, you will learn everything you need to get started with Python. Python is the most popular programming language out there and is used for so many different industries, like web development, data science, machine learning, or generally for writing automation programs to automate repetitive tasks. So learning Python is definitely a good idea. Let me give you a short overview of all the topics I'll cover in this course. After giving a short introduction to Python, we will start with the basic building blocks of programming. The most important data types like strings, numbers, lists, sets, dictionaries, Boolean data types, etc., and how to work with them. Learn about variables and functions and why we need them. Write a program that accepts user input and learn how to validate the user input using conditionals. Error handling with try except, and also learn loops with while and for loops, and again why we actually need them. You will learn all these concepts with hands-on examples. As a next step, you will learn how to modularize your program by writing your own modules and then see how to use some built-in Python modules. With all this knowledge, we can then build our next demo project to write a small program that accepts a goal and a deadline as user input and then outputs the number of days remaining till the goal deadline. Within this exercise, you will learn how to use the datetime module to work with dates. After that, you will learn about packages and comparison of package versus module, and we will use an external Python package in our next demo project, in which we will automate some tasks for working with a spreadsheet file. Finally, we dive into object-oriented programming. You will learn what classes and objects are in programming and Python specifically, and why this concept is so useful. In the final demo project, you will learn another common use case with Python, which is communicating with other applications over the internet by making a request to fetch some data from GitLab API. In this specific case, we will list the GitLab projects of a specific user. So that's what we're gonna learn. If you like this course, don't forget to give this video a thumbs up. I'm really excited to teach you all of this, so let's get started. First of all, Python is a programming language, just like Java or JavaScript. Python, compared to other languages, has two very big advantages. First of all, it's easy to learn. It has a simple syntax and it's very easy to set up and get started with. For example, compared to Java, where you need some initial configuration before you can even start your application. But it's equally or even more powerful than Java. Now, what makes a language powerful, or how can I say that Python is more powerful? Well, that comes from the ecosystem, which means libraries and modules that Python developers themselves develop, but also external developers create and maintain. So the more people adopt the language, the more powerful it gets because new libraries and so new functionalities get added to it. And the second advantage is that it's flexible. Now, what does a flexible mean in this case? What makes a language flexible? It is easy to mold to your wishes. So you're not limited or restricted by the language specifics like syntax or data types or some other constraints, or even library functionalities. You can extend Python widely, and as one of the results of this flexibility, Python also became a multi-purpose language, meaning it is used for many different categories. So let's see what these categories are. First, you can use it to write web applications. The popular libraries for that are Django or more lightweight Flask. Python became extremely popular because of the rise of data science, machine learning, and artificial intelligence industries. And more libraries were created and are still being added for Python for all of these categories. There are very popular and highly used libraries for data analysis and data visualization, libraries for artificial intelligence projects for things like face recognition, voice recognition, and a bunch of very powerful and widely used machine learning libraries. Python is also often used for data collection, like scraping the web, creating web crawlers. They're basically programs that collect data from internet, which you can save and then process later. Again, many different powerful libraries to do all of that. And finally, automation with Python. Python has many great libraries to automate DevOps tasks, for example, starting from CI/CD, pipelines to cloud platforms and monitoring your infrastructure, etc. You can also write Python scripts to do automated backups, cleanups on the servers, etc. In addition to DevOps tasks, you can also automate just general tasks with Python, like when working with Excel sheets, which is a common use case in many big companies, or automating some tasks on your own laptop. And there are also libraries for mobile development, gaming, desktop applications, but these are less likely use cases for Python because there are better alternatives for that. So you see that the use cases for Python are pretty vast, and it actually spans several industries. And it's mostly concentrated around data analytics, machine learning, and automation areas. And note that this isn't the case for many other programming languages. Usually one programming language is good for just few things, and you should use something else for other use cases. So now you see how useful Python knowledge could be and how it can help you in your job, but also make you more valuable at your work and for your entire team. I hope you are already excited to learn Python, so let's get started. As a first step, we're going to configure our local Python development environment. So the first thing we need is install Python locally on our laptop. So first we install or download Python package for your specific operating system, and then basically just click through the installer wizard to install Python locally on your laptop. And note that if you're doing this on Windows, very important step in the installation process would be to check the add Python to path option, basically, that you see here, because by default it is unchecked, and you have to check mark it so that after the installation you'll be able to execute Python commands in your terminal. Now, an interesting note here, if you're using macOS, like I do, is that by default on macOS there is Python already installed. So if I do Python version and execute, I see that Python version 2.7.10 is installed. And that is actually Python that macOS, the operating system itself, is using. However, for our tutorial and generally when working with Python, we want to be using the newest version, which is Python 3. So we're going to leave that default Python installation alone. We're not going to use that or touch that. And instead, we're going to be using the Python version 3 that we just installed locally. So now if I clean this up and we want to execute Python version 3 commands, we're going to do Python 3 instead and -- version, and that will give us the version. So that's how we can differentiate between the already installed Python and the newest version that we just installed. So just be aware of that difference. Now that we have Python available locally, it's time to download a code editor for Python, because we're going to be writing files with Python code, so we need a proper editor for writing Python code. And actually the best Python code editor available out there currently is PyCharm, which is from JetBrains. So that's what we're going to be using throughout our tutorial. So let's go to PyCharm. It is an intelligent code editor, which makes it much easier to write code. So it makes you actually very productive when writing code, and we will see why throughout the course. As you can see, there are two versions. We have the community version and professional one. Community version is free and already has a lot of powerful features, but the professional edition gives you additional very useful features, especially if you're creating web applications or scientific projects in Python. So with professional version, additionally, you will get scientific tools that you can use in scientific projects with Python. But also you get support for Python, web frameworks, and database integration, which can be, of course, very helpful if you're developing web applications. If you want to get the professional edition, JetBrains actually provided me with a code for my channel to try it out for 3 months for free. Just use my code when you install it. But for this demo, community version is absolutely fine. So I will go with this one and install it. And just click download. And once the PyCharm installer is fully downloaded, we can just click on it. Move it to the application. And now I can actually use it locally. So I'm just gonna open the application and we're gonna take a quick tour around PyCharm. It's actually pretty simple to set it up. And there you go, we have our PyCharm and we can now create a new project. And let's call it My Python Project. And that's it. Basically, we don't need to change anything else. And here you see the location basically of where this application folder will be created. You see PyCharm projects folder got created in my users directory. So this is basically very convenient because all my PyCharm projects or my Python projects that I create using PyCharm will be created in one location. And here you also see that Python version 3 that we installed is automatically being used for this project, which is exactly what we want. And you see it says base interpreter, and Python interpreter is basically a program that knows how to execute Python code. It will know how to interpret or translate our Python code into instructions that computer can understand. So with this configuration, we don't have to change anything. We're gonna create our project. So first of all, I'm going to make all of this a little bit bigger so that you can see the menu here on the side and the code a little bit better. So in preferences, editor, font, we're gonna set the size to 20. If I apply this right here, you see that this code editor font basically got bigger. And I also want to increase the size of this menu font here. So in appearance, I'm going to set it to maybe 18, and there you go. So basically everything is bigger now, so you can follow along and see exactly what I'm typing. And also another note here, if you want to configure your theme, basically, so if you don't want it to be dark or maybe you want some other color scheme, then you can select it here in appearance. You have 4 themes available. Let's actually try this one out and apply. And there you go, you have a different theme. I actually prefer this one, so let's leave it at that. So as you see, we have a very simple project with one main.py file. The extension is for Python files, which basically contains very simple code. And we're gonna basically just remove all of this and start from a clean Python file state. And in the next section, we're gonna dive right in and write our first simple Python application. We're gonna start with the simplest example in Python to basically learn Python syntax and get started as simply as possible. So first of all, we're gonna write a very simple application that just prints some output. And in Python, when we want to print, basically display results of what we wrote, we use this syntax where we say print, and here we can pass in basically whatever we want to display. And now if I want to see whether this super simple application works, I can run it or execute it with this triangle here, and I have the output. So basically the output is displayed or printed right here. And I see the output is 1. I can display some other values like 200 and run it, and there you go. Let's say we want to display some text. Basically whatever, some sentence, and again, triangle, and we have that output here, right? So again, very simple example of writing Python code that basically displays some information when we execute it. One thing that I want to note here is you see that we write some code basically in this window right here, so in our main.py file, and when we run it or execute it, our code, we see some display in this window. So you may be wondering, what is this window and why do we see some output right here? The answer to that is that whenever you are working with tools like PyCharm, which basically have all the functionality that you need to write your code and then execute your code, you basically have everything in one place. So whatever we write, we can execute or run right away. Now, without such tool, how would we write code and how would we execute that code? And this will help you understand what's going on here. And to show that, I'm going to go back to my terminal and I'm going to create a new file, and I'm going to call it test.py. We're going to write the same code basically in this file. You can do it in a file editor. I'm just doing it directly in the command line and save it. So now we have the same identical file as here, but not inside our code editor, right? Not inside this PyCharm tool. And we have Python 3 available locally. So now, how do I actually execute a Python file outside this PyCharm? I can do that using Python 3 test.py. And if I do that, I get the same output in the command line. So basically what you see right here, this whole thing is integrated. So basically all in one place where you can write your code, the editor right here, where you can navigate your files in your project. So basically this is just a folder on your laptop and you can navigate the files here, and you have the execution environment at the same time. So you don't have to go to terminal and execute Python 3, whatever, you have everything in one place. And tools that provide you with this type of environment for different programming languages, for Python it happens to be PyCharm, these are called IDEs, which stand for Integrated Development Environment. Integrated because you have everything in one place, so you don't need to use terminal. But in addition to this integration, you get more cool features which helps you in writing Python code. For example, syntax highlighting, highlighting errors, or code suggestions, autocomplete suggestions. And we will see those cool features actually also throughout this course. So basically it just makes your life as a developer easier. However, it's good to understand that connection between executing your files on the terminal when you don't have such a tool versus executing and working on your application inside that tool. Awesome, so let's get back to our code editor, a file where we write our code. And till now we have done something really simple like print a text basically and print a number, right? And this leads to the first concept in programming languages, which are data types. So in Python, just like in any other programming language, you have data types for text and numbers. The text data types are called strings. So everything within the double quotes is basically a string. But note that in Python, you can also use single quotes for strings. So double quotes or single quotes, they both work the same and there's actually no difference between them. And for numbers, we actually have different data types. So for whole numbers like 2, 20, but also 0 and negative numbers as well, we have a data type called integer, and that's also how it's called in most programming languages. However, you also have numbers for currency, for example, how much a product costs, right? So if you have an online shop, you would have prices like this, for example. So these are basically numbers with precision. This could also be, for example, when you're shipping something, you could have a weight of a package that is also not a whole number, but has a precision. So this type of numbers in Python and many other programming languages are represented as float data type. So again, you have integers and float data types. And if we execute that, you basically see all of that printed as we wrote them. Now, obviously, printing values like numbers and text like this doesn't make much sense unless we're getting some useful information from our simple program right here, right? So let's do something more useful with Python now. Let's clean all this up, and let's say we want to do some calculations. Very simple logic that basically calculates how many minutes there are in 20 days. So we have 20 days, which have 24 hours per day, which have 60 minutes per hour. So this line will give us basically calculation of minutes for 20 days. And there you go, that's our number. Now this makes a little bit more sense because now we have a program that actually does something for us. So basically, as you see, you can do any math operations on numbers in Python, and again, in many other programming languages, you can do plus, minus, division, whatever, just like you know it from basic math. However, I want to note right here something that many people think about programming and maybe are misinformed about, which is if you're doing web development or maybe DevOps automation with Python and not something like data science or data analytics, this is probably an example of the highest math knowledge that you need for programming in Python. Because even though we're going to use some calculation examples, because they're just good as examples to show you the basic concepts of Python, you do not really need any advanced or even intermediate knowledge of mathematics when programming, because it's really not about math. However, what you need is logical thinking, and we're going to be doing some of that and see that as examples. So just bear that in mind in case you are misinformed about that. So back to our example, we have this number that is displayed here as a result. However, maybe if we use this program, we don't remember or we don't know what this number stands for if somebody else is using. So we want to add some descriptive information about this number that says this is how many minutes there are in 20 days. So basically we need a line that says 20 days are this many minutes. And this should basically be exactly this calculation right here. So how do we put this calculation basically right here in the middle so that we end up with this whole phrase displayed right here? So how do we combine text and numbers basically, or calculation of numbers? And in programming languages, again, this is not specific to Python, we would do that using something called string concatenation. And string concatenation is basically a fancy word for gluing together or combining multiple strings. Now, how does the syntax for that look like? We combine the strings using plus sign. So apart from adding numbers, obviously using plus, plus is also used in programming for combining multiple strings. So in our example, we have 3 string values and we want to put them all together in one string or one sentence. We have the first string, 20 days are, and then we have the second string, minutes, and in the middle, the third string, which will be the value of the calculation. However, if we just put a number here, Python interpreter tells us it's not a string, it's a number. So we need to turn it into a string. Other programming languages do that automatically. In Python, we need to do that explicitly. So we need to tell Python, take this number, but not as a number, but as a string. And we do that using a syntax that looks exactly like that. So basically we have a non-string value, but we're telling Python we want it as a string because it needs to be printed out as a text basically. So if I execute this line, let's see what happened. And there you go, we have our output, just like we wrote it here, but you see that there are no spaces around. So basically 50 is just really glued together without any space around. And how do we put spaces around this 50? Basically add a space here, add a space here. Now, why does that work? Because this whole thing for Python is a string. Again, because we are putting it within these quotes. So basically any character that you see on your keyboard right now, if you put it between those quotes, is interpreted by Python as a string, including the space character, right? So if we execute it again, we have spaces around 50 and our sentence, our phrase, looks fine. And if you're thinking right now, this is actually kind of annoying because first of all, it looks ugly and also there's a high chance you're going to forget it. That is absolutely right. So in Python, again, specifically, there is a way to do it in a more elegant way using a different syntax. And the more elegant syntax for that, let's actually close this, is print. And let's write that again. And instead of having this plus, we have curly braces and we write our number inside or whatever non-textual value. And at the beginning right here, basically before we start writing a string, which starts with quotes, we just write the letter F, and you see the syntax highlighting as well. Basically sees that this is not part of the text, this is non-text value. And if I execute it, I should see the same output from the second line. And this is really a way cooler way to write this instead of using plus. But this is something very common and also something that you would encounter in most programming languages. So just important to know that this is a syntax for string concatenation as well. So we can basically just remove it and use this syntax for our examples. And also note that this syntax is actually a new addition to Python, so it only works if you have a latest Python version. In our project, if you remember, we actually configured and chose version 3.9, and that's why it works for us. If you use Python 2, for example, Python version 2, this syntax is not going to work for you. We can actually demonstrate it, so I'm going to copy that line. And I'm gonna change our test.py. And now if I execute it using my Python 3, you see it works fine. If I do it with Python, which is version 2 point something, let's see what happens. There you go, syntax error, invalid syntax, because Python version 2.7.10, so older version, basically doesn't recognize this syntax. So just be aware of that. So this syntax actually only works for Python versions starting from 3.6. So everything below that, every Python version basically will not recognize this syntax, as we see right here. So again, back to our code, and now we just have a number here, but what we actually want is the calculation for getting the correct result, right? So we want, again, 20 days in hours and then in minutes. And if I execute it, you see that the calculation was done. And here we have a full complete sentence with the result in it. And if you're curious, this F actually stands for format. So this is basically formatting our text or our string in a correct way. Awesome, so we have this line of code here that basically calculates for us how many minutes there are in 20 days. Let's say we want to do the same for 35 days, right? What we can do is basically copy that line and replace the values for 20 with 35. And if I execute it, I get the same calculation but for 35 days. And we can do that basically multiple times for different values. So let's say we want it for 50 days and we want the same calculation for, I don't know, let's say 110 days, doesn't really matter. And we have obviously different number of minutes for each of these values. And now let's say we wrote this program, it's ready and we're using it. And at some point we decide, you know what, I want this program to actually calculate how many seconds there are for these provided days instead of minutes. So what we would need to do in that case is basically change the calculation in all those 4 lines. So instead of minutes, it should actually calculate number of seconds in a day, right? So we have the hours, minutes, and seconds. And we would have to change the text as well here. And we would need to do that for each one of those lines, right? So we would have it here like this. And again, if we need to modify this for hours or milliseconds or whatever, we basically have to do these changes multiple times, right? Even though if you actually look at that, this is the same exact calculation for each line that doesn't change, right? If you want seconds, then this is the calculation that you need to do. So how can we actually avoid repeating the same calculation and the same text in our code? And the answer to that is variables. So in programming languages, we have variables that basically hold values that will repeat throughout your code that you can set once and use it in multiple different places. So instead of basically repeating this calculation 4 times, we basically do this calculation once like this, and we basically save this value in a variable so that we can use it whenever we need, right? And the way that variables are defined in Python is variable name. Let's call it 2 seconds equals, and whatever that value is that repeats itself and that we want to save into a variable. Now, I want to make 2 notes here regarding the variables in Python. First of all, in Python, defining or creating a variable and giving it a value like this, the syntax for that is actually very simple compared to other languages because you just have the variable name and the value. In many programming languages, you actually have to define here some kind of data type for that variable. For example, if it's a number like float or integer or string, etc. In Python, you don't have to define that. You just have name of the variable, simple as that. The second one is the naming convention or standard for the variables. So we have 2 words. For example, if we name our variable calculation to seconds, right? We have actually 3 words here. So variables that are descriptive, so basically they tell you what this value actually is about. So they have multiple words in them. You can separate them using these underlines. Again, in different languages, the naming for variables can be different. In Python, this is actually one of the standard ways of defining variable with underscores, which I find pretty nice and easy to read. So we're going to use this syntax basically throughout the course. It will be totally and absolutely okay if we wrote it like this, or if we used capital letters instead. But again, this is probably the most readable form, and this is what we're going to use. Now here note that we can decide whatever name we want to give our variable. But in Python, there are some specific words that have special meaning to Python. These are called reserved words. So you can't use these words as variable names. And we will use some of these reserved words throughout the course, so you will see some examples. Great, so we have our variable defined here, and this is the value that this variable gives us. So how do we replace now these repeating values with this variable? So we're going to delete that, and again inside we're simply going to copy the name of the variable. So let's execute, and as you see we have our value printed just fine, and we're going to do the same for all those values. And again, execute. Everything works just like before. Now you may be thinking, if we change this to minutes, we would have to change the variable in all these places. So if that's our case, we can basically just rename our variable something more generic. So let's say calculation to units, and this could be now any unit that we want. Second, minute, doesn't matter. And this is exactly the advantage of variable, because you can name it whatever you want, which basically just describes what this variable is about, and now you won't have to change that again. And we can also replace this one here accordingly. Since it's a text, we can call it a name of unit. We can also call it unit, doesn't really matter. We're the ones deciding what that variable name is. And once we have that variable, we can now replace it here. How do we do this? Because this is actually part of a text, a string, the same way we did right here. We're gonna delete that and create an expression, or create a syntax that basically tells Python, hey, this is not a string, this is a non-string value. And you already know this could be either number or variable itself. And so we're gonna use the curly braces and the name of the variable. And just like that, we have substituted these values here. And if I execute it, works perfectly fine. And we can do that in all 4 lines, and our code is still working. And this syntax right here with this format at the beginning basically prevents us, or avoids, basically saves us from having a bunch of plus signs here and then space characters, etc. This all looks way elegant now. And now if at some point we actually decide, you know what, I want this program to calculate how many hours there are in the given days instead of seconds, and we want to change the program to do that, we could basically just change the calculation here, and instead of seconds we have hours, and if I execute, there you go, we see the changes right away. So this is why when you're programming, doesn't matter in which language, including Python, using variables will be probably some of the most frequent thing that you do, because you always have values that are repeating themselves and you want to write clean code, so you create variables. And one of the best practices when creating and using variables is, as we're using actually here, is to name your variables so that you later, and also other programmers who are working with you, understand what this variable actually does, or what type of value it actually has. Because if you just look at 24, you would probably not know what this 24 is about, right? But with variable, you actually know that this actually represents a number that is used for calculating units, right? It could also be more descriptive, like units for days, but generally another advantage of variable is to basically describe that value as well that you're using in your code. Now, another thing you probably also noticed is that even though we're using variables here so that we don't have to change those values in 4 different places, a lot of these 4 lines are actually pretty similar. The only difference in those 4 lines are actually these numbers right here. Everything else is exactly the same. So what if instead we wanted to make this code cleaner and basically avoid this type of duplication in our code, right? So for example, if we did this for 10 different values, we would have the same line, this long line, basically 10 times, right? So how do we avoid this type of duplication? So right here, we actually avoided duplication for specific values, right? Piece of string here, a whole calculation here, but how do we actually avoid duplicating a whole line, right? The whole piece of code basically, which has multiple different stuff in it, not just a value. And we do that using functions. So functions are basically blocks of code like this, right? Or basically logic in code that does something. It's not just simply a value, but actually does something more complex that is again used in order to avoid repeating the same logic or most of the same logic in your code. So how do we create functions? Just like we created variables here, we create functions. And the way we do that is using following syntax. Right here, let's create our first function. We start with def. So we define a function, just like we define a variable, but for function, we need this keyword basically called def. And now we can give our function a name. Just like we gave name to our variable, we can give our function a name. And here we can use the same standards like for variable. We can name the function something descriptive, something that actually says what this function does. And let's call our function days to units. And then we have the brackets and a colon. So this line basically defines a function. It tells Python, hey, whatever comes after this is actually going to be a block of code that is going to be referred to, or is going to be named days to units. And how do you write a function? I'm just going to copy this one actually here, and let's give us some space. And again, this is very specific to Python. We need to indent here with spaces. And I'm gonna paste in what I copied inside. These 2 lines basically tell Python this piece of code, or this line of code, because we just have 1 line here, belongs to a function called days to units. And again, we just have 1 line, but this could be function with hundreds of lines, right? So I can write whatever I want on the next line, all good. And then I can do some calculations, and I can basically write whatever logic I want here, and all of these will belong to this function. So now this logic is inside a function that is called days to units. And we can actually get rid of this and test our function. And here, if you noticed, we have this yellow line under the function name. That's actually a warning for our code style. It says we need 2 blank lines before. So PyCharm has a built-in official style guide for Python that tells you how to style your code or how to write your code correctly. Now, why is code style important? Well, just like you write code, you need to read code from other developers or your own code to understand what the code is actually doing. So it's important that code is easily readable. And this is just another example of how an editor like PyCharm helps you to write code. So to fix the warning, we're just going to add a new blank line before the function definition. So now what happens if I execute this block of code? I have the variables defined here that I'm using in the function. And then we have these 2 print statements. So what happens if I execute now? And as you see in the output here, there is no output, right? Nothing actually got printed. So what actually happened, because we have those 2 print statements that we defined in the function, but we don't see anything in the output. And the way it works is whenever you create a function or define a function like this, you actually have to use that function, right? Again, this is a similar concept to variables. We have created variables here, and we're using that variable in our code. The same way we create a function and we need to use that function. How do we use a function? Or in programming languages, it's called calling a function or executing a function. And we do that using the name of the function like this. And as you see in the suggestion as well, using brackets like this. So this syntax here basically is what we call calling the function that we defined right here, or using that function. So now if we execute it, there you go, you see that those two lines got executed and we have the results here. So we're creating variables and we're using that here. We're creating a function and we're using that function here. And note the difference between using a variable and using a function. Python knows this is a function because we are providing these brackets at the end, right? That tells us we're making a function call, basically. But as you see now, we have these 20 days, so this only works for 20 days, right? What about other values that we had? What about 35 days and 100 days? We haven't deduplicated that, right? We have just one case here. So how do we use functions so that everything else except for these two values right here actually stay the same? And we do that in programming by giving our functions some kind of input value, which are also called parameters. So instead of having this 20 basically here, hard-coded, as we said, here and here, we provide that value of 20 or 35 or whatever that value is, basically, whenever we use that function. So we are telling Python, use this days to units function with a value of 20, or use that function with a value of 35. And the way we define this input parameter in functions is very simply by defining this parameter between those brackets, right? So this is where the input, we as programmers define the input parameters. So right here, how do we define that? Using our already familiar variables. So basically right here, I'm gonna define a variable and I'm gonna call it whatever I want. I'm gonna call it days or number of days. But I'm not assigning a value to that variable, right? Like I did here, because I want it to be assigned whenever I use the function. So this basically tells Python that a function days to units can be used using one input parameter, which is called num of days, right? Number of days. So now the last part which is remaining is replacing these values using this variable, right? And just like we do it in these two places where we're also using variables defined here, exactly the same way, we're gonna remove this and define a block for non-textual value, and we're gonna put our variable num of days here and also here. So you see now that our function actually doesn't have any fixed numbers in it. Instead, we're using variables. We're using two variables that are defined outside that function, and we're using one variable that is defined within that function, right? This variable actually belongs to that function. And now, as you see, whenever we want to use that function, we're telling Python, hey, call this function called days to units with a parameter, an input, basically, of 35. So now if we execute it, by the way, we can also do it here. You see, 35 days are, and the calculation was done here, and hours. And now if we go back to our previous example, where we wanted to calculate these for 4 different values, right? 4 different number of days, we can actually do the same. So we had 20, then we had 50, and we had 110, right? So this basically gives us exactly the same logic that we had previously, but with different syntax, right? So you see the difference, that instead of having this basically 4 times, we have much cleaner syntax where we actually see what this logic is doing, which is days to units. And then we have the number of days that we pass or give our function as parameter. And if I execute this, you see that it was printed 4 times for all different values. We can actually remove this line. And now if we make some change in our function, for example, we change the name of this variable. We want it to be hours instead of units. We just do it once in one place, and that's basically it. So whatever changes we make inside that function, and that is actually the big advantage of using functions in code, whatever change we make inside here, it doesn't affect how we use the function, because for using the function, we only need the name of that function and the input parameter. Now, probably you're wondering what happens if I do not give my function a value. Let's delete those lines, and let's say we do not provide any value here, and we try to execute or call our function without the parameter. And let's execute. And you see that Python interpreter is complaining because we have told Python, here is a function called days to units, and whenever I want to use that, or my colleague, another programmer, wants to use that function, they have to provide an input value here, right? So now whenever Python sees the usage of that function and there is no input parameter that we are giving that function, it cannot execute that function, right? Because basically this value is missing here, right? And that's why we get an error, which also says missing one required argument. So as you see, whenever we define a function with a parameter, with input parameter, we have to also provide that input parameter. Another thing that you may be also wondering is, what if I want to provide multiple input parameters to functions? How do I do that? It's actually very simple. You can do that by simply defining here another input parameter separated by comma. And let's say we want to pass here something that we want to print out additionally, like a custom message, doesn't really matter. And the same way, exactly the same way as the first one, we can actually use it in here. We can even create a new line and basically just print out that message, right? And note that if you are using a variable without string, so basically it's just the variable itself, we're not using any text. In that case, you don't need this format, right? So you can basically just print it out directly. And now again, we have told Python, I have this function and 2 input parameters are required. So I also need to pass 2 input values whenever I use that function. So now let me just pass in some custom message. Let's say I'm happy about the calculation, or I know I'm gonna be happy. So let's say awesome, and let's do another calculation, and this time I say looks good. And if I execute it, you see that I get awesome the first time, and then for 35 I get looks good. So you can basically define and provide as many input parameters as you want. Common practice, and also what you will see in just normal code basically, is just a handful of input parameters, maybe 1 or 2. So it's not actually overloaded with 10 parameters. Cool. Now that we know functions and variables, why they're used or why are they useful and how we use them, there is one point that I want to mention, which is variable scopes in functions. What does that mean? As I mentioned previously, in this function we're using multiple variables, right? We're using 2 variables that are part of the input, right, that we provide when using the function, and we're using 2 variables that are defined outside the function, right, somewhere else in the code. So variable scope basically means where is the variable that function uses defined. And variable has a global scope for a function if it is defined outside the function, like these two variables right here. Could be completely in a different file, not even in the same file where the function is. So these are global variables. So all the functions that you have in your Python code can use those global variables. And then you have local variables. Local variables are variables that are created within that function, right? So these two variables are basically only available inside that function because it was created within that function. So internal scope and global scope. So that means that when we create another function, let's call it scope check because that's what we're going to do. We want to test the scope. In this function, I can access the global variables like name of units, but I cannot access the internal variables like number of days. And let's actually test that. So I have num of units, which is a global variable defined here outside the function. And the second one, I have a variable that is defined inside another function, right? So as I said, internal. And as you see right here, we already get a red line underneath that says unresolved reference num of days. So for this function, basically that variable is not visible, it's not accessible, it doesn't exist basically at all. And we can even test it out actually. So again, if we want to see the results, we have to actually use that function like this, run the function, and if I execute it, you see that we get an error that says name num of days is not defined, right? It doesn't know that there is a function like that anywhere in code. However, it does recognize the global variable. And that means that variables defined outside function itself, global variables are accessible to all the functions. And if you have variables defined inside the function, then they're only accessible for that specific function and not for other ones. And that means actually that if num of days variable does not exist for scope check variable, we can actually create a variable inside scope check with the same name, and we would have basically no problem at all. So this is not going to be a duplicate because this function doesn't know about this variable, the num of days here, and scope check doesn't know anything about variable num of days right here. And if we want to use that function now, we have to provide the value. Let's do 20. And if I execute, there you go, you have name of units and the 20 that we provided. So global variable, local variable defined here. Another interesting thing is that, as I said, inside the function body, so to say, so this is basically whatever is part of the function, right, in this indentation is called function body. So we can create whatever logic we want inside that function body. So whatever I can do in Python, generally, I can do inside the function body. So one of those things is actually creating variables, right? Just like we created variables here, we can create variables here like this. Let's call it my variable and variable inside function, and we can print that out as well. So now we have three types of variables that we are using in this function. We have a global variable, we have internal variable that is passed in as a parameter, and we have internal variable again that is basically defined. So the variable isn't provided when we use the function, but it's basically just defined inside the variable. And again, if I execute this, see hours, num of days, and variable inside function text printed out like this. And obviously this is just for demonstration, but we're gonna see more realistic examples of that in our projects. So I'm gonna clean this up And we can move on to the next concept. So now let's go back to the example where we calculate number of hours, and we do that for 4 different values. Now, if you want this application to be really useful for us or somebody else, it doesn't help that we have to fixate here just 4 different values, right? The application should be able to take any value that we basically feed it, right? So we should be able to provide any number of days, and the program should calculate the number of hours in those days. So what we need here is user input. So when we give this application program to somebody else or use it ourselves, it should allow some user input. So how do we write a program that asks for and accepts a user input and then does something, some kind of calculation, some kind of other logic based on that user input? Accepting a user input from a Python application is actually pretty easy. Let's get rid of all of these lines first. And we can do that by writing input. And this will basically give a user a prompt to enter some input value. Now, you probably already see from the syntax that this looks very much like using our days to units function, right? In this case with a parameter. So input is actually a function that Python provides us with. So we didn't have to write this input function, right? We wrote the days to units function, but input function is available in Python so that we can use it whenever we want. And this parenthesis here tells Python we want to call an input function. And we're calling it or using a function without a parameter. So now we know that we can write functions ourselves for logic that we need, but Python has tons of functions that Python developers already wrote and is part of Python, and we can use it in our code so that not everybody has to write their own input function logic. And the code or the functions that Python provides are again part of this Python that we use in a project. And obviously, if you're using the latest version of Python, you will get the latest code and latest functions that Python basically provides. So back to our function execution, and let's see what happens when we execute this program. I'm going to run it, and in the output, you actually do not see anything other than my cursor is blinking here. So it's actually waiting for user input. So I can actually type in something here. So I can do 20 and enter, and process finished with exit code. So I was able to input something, doesn't really matter. It could also be a string actually, doesn't really matter. And program basically finishes. So that's the simplest usage of input. However, as you noticed here, running this program and basically having this blank output here is a little bit confusing. So if another user is using our program, they will probably be wondering what's happening here. So what we can do is in input function, we can provide a parameter that actually tells a user something, right? Like enter a value for number of days or something similar, so that it's not just a blank prompt, right? So we can do that by passing in a parameter, a string, which is going to be our message. So we can do, hey user, enter a number of days. And I will convert it to hours. And here you see right now that the program wasn't finished because we didn't enter anything. So this program finished line wasn't output yet. And that means the program is still running. It is still waiting for our input. And in PyCharm, in this IDE, if you want to terminate the program manually yourself, you can click this stop button. And as you see, process finished. So now we can run the program again. And as you see here, we already have a message that we're displaying to the user so that they can enter the hours, right? And here we can provide our input 30, and there you go. However, this doesn't look nice here. We actually want the user to get a prompt on the next line. How do we do that? As part of a string, we can actually add a new line, or new line character basically. And that in programming is actually represented by \n. And you see a special highlighting for that one. Now let's execute. And you see that my cursor is on the next line now. And again, let's provide a value, enter, and program ended. So we have now a more user-friendly way of asking program user for their input instead of just showing an empty prompt, and we're getting user input. Now, we're not doing anything with that user input, right? That input basically just finishes the program and that's it. We're not doing any calculation for that input. So how do we use the value that user enters here when input function gets executed? We do that, and this is a very important concept, by assigning whatever result this function usage gives us, which is in this case a user input, assigning that result to a variable. So right now it's basically executed and it's just wasted, right? It just disappears. So instead we want to save that value, that entered input value, in a variable so that we can access it later. And we do that by, let's call it user input variable equals. So just like we created variables here with variable name and a value, right? Or even an expression, right? If we did a calculation here, that will be basically a whole expression, whole calculation. The same way we can use values that function execution gives us to assign it to a variable. So now what I'm gonna do is I'm just gonna print the user input so that we can see what value that user input variable has. So let's execute again. It asks for our input. Let's put 20, and print user input gives us 20. So user input variable value basically becomes whatever we provide as an input. Now that's a new concept and it could be a little bit confusing. So let's see another example with our own function. What would happen if we assigned value of this to a variable? We get a warning, as you see here in the editor, which is one of the great things about IDEs, that it basically gives you warnings when something is not correct. And the warning says function doesn't return anything. So basically, if we want to have some value as a result of function execution, we have to return some value in the function. And how we do that? Instead of printing the value right away, we can actually return that value using return keyword. Again, you see special highlighting here, just like here, because return is a special word that Python understands that you want to basically give back a value, this value right here, as a result of using the function, right? So you could have some logic here, doing the calculation, whatever, and then as the last line, you can return that calculated value. And now the warning is gone because we're actually returning something from the function. And when we return value from a function, again, we can assign it to a variable so that we can use that value, whatever function returned, by referencing the variable. And one of that usages will be basically just to print it, just like we did before, like this. Let's delete it temporarily and test our program. And there you go. You see that this function got executed with input 20. This text, this display text basically was put together in the function and was returned or was given back as a result. And we saved that this whole string, basically this whole sentence, in a variable called myVar. And when we print that myVar, we see that value printed out here. And again, if we enter some other value, we would get different text. And again, that is actually a very important concept of giving back some results from a function execution. And you saw in our examples that you can have a function that doesn't return a value, just prints something or maybe does something else, or function that returns some value. You can have both types. So back to our example of user input. So now hopefully it makes sense that input function returns whatever value the user entered as a result, and we can save it in a variable and then access it later. Again, let's get rid of this line, and now let's actually do the calculation on that user input number of days. How do we calculate number of days? Very simple, by calling our function that actually does that. So we're gonna call our function to calculate the number of hours for an input, and the parameter that we pass in is going to be whatever the user provided. So instead of basically hard coding a value here ourselves, we give it a value that user provided instead. So the num of days will be the user input. And now, again, because this function returns the whole string, it doesn't print it, remember? It just returns it. So when I execute this and I provide in some value, let's do 200, you see that I don't have any output here because we didn't print anything. We basically just returned the value here. We didn't do anything with it. So the last piece missing here is to display the text, the string that function returns. So we save that return value first. Let's do calculated value. So we save this thing in calculated value variable, and finally we can print it. And now let's execute it and let's see what happens. I'm going to type in 10 days, and let's see what we get now. And you see we have this weird value here as a result of the calculation. So what exactly happened? So this part of calculation, basically, which represents this number, didn't do a proper calculation. And the reason for that is because the input value that we get with input function is always treated as a string and not a number. So basically, at this place here, number of days input, 10 here, is actually treated as a text and not a number. And where this weird result comes from is basically number 10 printed out 24 times. So instead of doing the actual calculation, 10 times 24, 10 is printed 24 times. And that's what happens when this is interpreted as a string. So how do we make Python see that number, see that input value as a number, as an integer, and not a text or not as a string? And it's actually pretty easy to do. On the next line, the user input, again, we saw right here, it is a string. So we have to make it into a number. And we're going to do that using int and user input. And that process of turning a value from one data type into another is called casting. If you remember, we already saw an example of it when we turned a number into a string in the string concatenation example. Again, from the syntax, you should already know that this is a function call. So we're calling a function called int, again, that Python itself provides us with because we didn't write that function, and we're passing in one parameter, which is a string, and we should get an integer from that string as a result. And we can save that number into a variable, and let's call it user input number. And now we have 10 as a number instead of as a string. And instead of passing in that string user input, we can now give our function number that it expects. Let's save it and execute. Let's put in 10, and there you go. Now the calculation is correct. What I want to show you now is how this user input actually works without a code editor like PyCharm. So I'm gonna copy all this code and let's go back to our terminal, and in our test.py I'm gonna paste in our code and save. And let's now actually see how the user input works when we execute it in a simple terminal window. And as you see here, we have the message first, and the prompt is right here. So we can enter a value. Let's do 25, enter, and we have a result. 25 days are 600 hours. Great, so our program is working. It is converting the number of days to number of hours and accepts a user input. Now, what happens if a user enters an invalid value here? So for example, instead of a positive value for number of days, maybe they enter a negative value like -10, for example. And obviously that input value doesn't make any sense, but we are still calculating and giving a value, right? And this is another important concept in programming generally, that when we allow users to give our program some input value, we also want to restrict them and basically validate that what they provided as input is a valid value for our program specifically. One, that it makes sense, like in our case, -10, program still does a calculation, but it doesn't really make sense. And second, it doesn't crash our program, right? So now let's see what happens if we enter some text here. You see that the calculation didn't happen because we basically crashed the program, the application, using that invalid user input. Doesn't make sense, or an input that crashes our application because the calculation isn't even possible. And we want to avoid users basically either providing a nonsense value or a value that will crash our application. So we need to validate user input. And this is, again, important concept in programming, because whenever you allow user input, you always have to validate it. So in this part, we're going to learn a concept called conditionals, and we're going to learn this concept with an example of validating a user input. So where are we going to do the user input validation? We can do it in our function. Right before we actually do the calculation, we can first validate, is it a positive number and not a negative one? So user gives us their input, we convert it to a number, and then we pass that number to our function. So -10, +10, that as a number basically will be passed on to our function. And right here, we can check whether this variable value here is a negative number or not. How do we do that? We do that using if-else conditional statements. So very simple and intuitive to understand. We say if number of days is greater than 0, means it is a positive number, then we want to do the calculation and return all of this. But you see that we have a red line here. So basically, whenever we use if condition, we have to have a proper indentation. So all of this line basically goes indented for this line. Kind of the same way as we indented the whole function body inside the function. Whatever logic and whatever code is right here indented below the if condition will be executed if number of days is really greater than 0. So let's try that again. I'm going to execute it. Let's put a +10. You see 10 days are 240 hours. Got calculated. Now let's put -10 as an input. And you see none, basically no output for us because this line didn't actually get executed for -10 input value. Now, what if we want to tell a user hey, this was an invalid value and that's why we didn't do the calculation, instead of just showing none. We can do that by returning this feedback message or error message whenever this is not true. So whenever number of days is not greater than 0, we want to return something else, right? Another message. And we can do that using else. And the same way as for if, we have the indentation, and whatever we write here will be executed if number of days is not greater than 0. So here we are going to return you entered a negative value, so no conversion for you. And here it's time for another special term in programming. That greater than sign is called a comparison operator. And we have 3 of them. We have greater than, less than, and equals. And these are called comparison operators because they are used in an operation to compare 2 values. And before in this course, we learned arithmetic operations like plus, minus, divide, multiply. So again, fancy words for simple concepts, but these are the official terms for this. So now if someone mentions them, you will know what they're talking about. So now let's execute the application and let's provide -10. And you see that this line was printed as a feedback to the user. So to go through the flow again, user gives us their input, in this case -10. We convert it to integer, so now it's -10 integer, and we pass it on to our days to units function. And days to units function basically has this if-else statement. That's how it's called in programming. And our if-else statement validates or checks whether this input is greater than 0. If it is, then the function will return this as a result. So basically the calculation with the proper message. Else, so basically if this is not the case, then it will return basically just a feedback message for the user. And note that else doesn't have such a check. Here we don't check number of days is less than 0. And the reason for that is because it doesn't check for less than 0, because it basically just decides if this is not true, else, or in that case, just do this. So we don't need additional check here. Now, this segment right here, where we're doing the check, is called a conditional. So basically we're providing our program a condition. If this condition is correct, then do something, otherwise do something else. And that conditional can be true or false. If we enter 10, then this conditional will be true because it's greater than 0. If we enter -10, then this conditional will be negative. It's not greater than 0. And those true and false values in programming actually are represented by its own data type, which is called Boolean. And in order to show it to you that this conditional either gives true or false, what I'm going to do is I'm going to print this conditional right before I do the check. So for a positive number input, this should print true. And if it's negative, so it's not greater than 0, this should print false. So let's test that out. First, I'm gonna provide +10. And right here, you see true, because this condition is indeed true. And note that this is not a string, that's why we don't need the quotes here. So we can basically just put in the whole expression in a print function. And now let's do the same with -10. And you see false. And as I said, true and false values belong to its own data type in programming, which is called a Boolean. And again, we can demonstrate that. Instead of printing it out, we can save it into a variable. Let's call it conditional check. And in Python, there is a function called type, which checks or prints out basically a type, a data type of a variable or a single value. So if we pass it, so this will give us the data type of conditional check. And obviously, if you want to see that result, we need to print it. So print the whole thing. So it doesn't matter what we pass in this point. And right here, you see class Boolean. So this conditional check here, which has a value of true or false, is of type Boolean. Now there are two things that I want to note here. The first one is that you see that I am calling a function here, which is type. And then whatever that function type returns, which is basically this output here, we are printing it. So we have two function calls that are basically nested. And that is absolutely fine. You can nest function calls. Another example of doing this nested function call would be, for example, right here. Instead of assigning this to a variable and then passing it here, we can actually save as that step and in the days to units function call, pass it as a value. So this is a perfectly valid syntax and you can do that. You can nest in the function calls and you would not need this additional step. And you can do that as many times as you want. It just looks cleaner when you have that syntax a little bit separated and not have 2, 3, 4 function calls nested. So that's one thing. And another thing is we just saw a class Boolean type here. And let's actually see that same output for string and number. So just for the demonstration, let's actually see the type of string and integer. Let's get rid of this for a second because we just want to test. So we're going to print the type of a string, which says this should be a string type. And execute. And you see class string. And now let's provide an integer. You see class int. And let's provide a float. And there you go, we have float. So this is a very handy way of checking the type. And we're going to need that actually in a later example. So back to our application. And one note about Booleans and conditionals is that you're going to be using a lot of those in programming because they're really the major or the core part of writing any kind of logic in programming. So you're going to need if-else conditions and statements and Booleans in your application. So it is a very core concept and we're going to be using a lot of them in our coming examples. So let's get rid of this code right here. And one note before we move on here is that the negative numbers are not being calculated because of this condition. Now, what about 0? Let's actually try that out. So I'm going to enter 0, which is actually also a value that doesn't make sense because 0 days input obviously will give 0 of any units. So enter. And right here you see a feedback to user that says you entered a negative value, so no conversion for you. And the reason for that is because this condition here, number of days, checks greater than 0, which means that negative numbers and 0 will not match this condition. So they will basically give you this feedback. But our message says you entered a negative value, right? When we entered 0. What if we wanted to have a specific message for a user if they enter 0 and a specific one if they enter negative value, right? We want to differentiate between those two. How can we do that? In the if-else statement in programming, we can have multiple conditionals. So basically we can have multiple ifs. So how do we do that? First we check number of days is greater than 0. Okay, great. Now we want to check whether number of days is equal to 0. And we can do that using another if here. And in Python, the syntax for that is elif, which basically is a combination of else and if. So if this is not true, then we want to check another condition, number of days equals 0. Now you know the equation sign generally is this one right here. However, when we're checking whether something equals to something else in programming, that equation check is represented with 2 equal signs. And the reason is because one equal sign is already used to represent assigning a value to a variable. So not to confuse those two actions in programming, we have 2 equation signs when we want to check whether something equals a certain value. And just like here, we execute some logic whenever this condition is true. So in our case, we want to tell the user, you entered a 0, please enter a valid positive number. So now, again, to go through this logic flow, if the input value is a positive number, then function will return the calculation and the message. If it's not a positive number, then we will check additionally whether it's 0. If it's not 0, then this is a last condition basically. Then we know that it has to be a negative number, right? So let's test this out. Let's enter a positive number. There you go. Let's enter 0. You entered 0. Please enter a valid positive number. And let's enter -1. And everything works perfectly. Note that you can have multiple elifs between if and else statements. And again, note that elif has a condition, just like if statement, else does not have any condition. So this is like the fallback. So if everything previously stated, all the previous conditions did not match, so they were all false basically, then this is the logic that will get executed in that case. Great, so we have validated input value for users, and we may feel pretty good about our program because it doesn't calculate anything for values that don't make any sense. However, we still have a problem. What happens if a user enters a text instead of a number? So basically anything that is not a number value. Doesn't really matter, basically some text. And if I enter, you see that our program actually crashed. And this is actually a user input that we want to protect our programs from, because we don't want to allow users to blow up our application, right? So let's see what happened. It actually says that we provided an invalid literal. Literal basically means the text itself or a number, so basically a value that we entered for int function. That's the problem. So this function call basically just blew up because int function expects a value which is a string representation of a number. So basically int expects something like this or something like this. It doesn't expect my text or some text. So our application crashed on some text input. Now let's see what happens if I provide a number but a float number instead of integer. Let's enter 19.99 and enter, and you see the same error. This function basically returns an error because it cannot convert float into integer as well. So we have a problem here that whenever user enters anything which is not an integer, our program will blow up. So how do we avoid that? So basically, before the int function gets executed with an invalid value, we need to validate this whole thing and stop our program before that happens. So we need the validation before int gets executed. And we can do that right here, right? So before that line gets executed, we're going to do a validation. And one way we can do that is using our familiar if-else statement. So we can say if user input is digit. So again, from the syntax, you know this is calling a function, but note that instead of calling the function like this. So basically just stand alone. We have the syntax where we have the variable dot and then the function name. So instead of passing this as a parameter right here in the function brackets, we are passing it as a parameter again, but using this syntax, right? So isDigit function will execute for user input as a parameter. And again, in if we have conditions, so this will be either true or false. It's a Boolean. And if user input is digit, it's a number, basically. So basically, this will filter out input values that are text. So basically, they're not numbers. And if the input is digit, then we want to execute this line and also the rest of our application like this. And if it's not true, so if the user input is not a digit, we don't want to execute anything in our application. We want to stop the execution and want to tell the user this was an invalid input value. I'm not doing anything with my program so that it doesn't crash. So else, if not digit, we are telling the user your input is not a number. Don't ruin my program. So now let's actually test it. So I'm going to execute and write some text. And there you go. So user input is digit was evaluated to false. So none of these got executed. Instead, the else block was executed and it printed a message for our user. So we basically avoided our application to crash with this check. And if we try a proper number, it works. And if we enter 0, for example, the application will get executed and we will get our message from here. So our application is more or less protected and we're not allowing for an invalid input number. It's not a valid number. Now we know that in programming there are different types of numbers. We have float numbers as well. So let's actually see what isDigit function really checks. So let's actually try to provide a float number instead of integer, which is not a proper valid input for our program. So I'm going to type in 19.99 and you see that isDigit is false for a float number. So we got the same, your input is not a valid number output for float number as well, which is perfect. It's exactly what we need. And now let's actually try to enter a negative number and let's see if isDigit function returns true or false. I'm going to enter and you see that else block got executed because isDigit was false for a negative number. So basically this function filters out a lot of the bad input for us to protect our application from bad user input. And that also means that we don't need a check for negative values anymore. And by the way, in Python, you can actually have if statement without an else at the end. This will work perfectly fine. And this could be our application. However, note that in programming, we don't put this type of logic directly like this, basically outside of function. As a common and best practice, we encapsulate or most of the logic basically in functions. So as a cleanup for our code, we can take all this and put it into a function. So right here, I'm going to create a function and let's call it validate and execute or something like this. And all the logic that I copied will be just simply pasted in that function like this. So now we have that logic nicely encapsulated in its own function. But as you know, when we create a function, we have to call that function, otherwise nothing happens. So we're gonna call it right here. We don't have parameters and we don't have to provide user input because user input is a global variable. So our function has access to it. Let's actually test it out. And it works. And let's provide some bed input. And it works too. So that's actually a proper way of writing code, of having every piece of logic in its own function with a proper description for the function. Now, as a next step, I want to show you also a concept or something that you will encounter very often in code, which is nested if-else statements. And I'm going to show that example by cleaning up our program a little bit. So as you see here, we're doing validation in two different places. So we're validating user input here, but also inside days to units function itself. So what we can do is we can put all the validation in one place in this validate and execute function and basically have all the validate logic in here. And let the days to units function just do the calculation and not the validation. And this way our functions and code will be a little bit cleaner and more logically built. So after we validate that user input is a digit, we convert it into an integer. So right here we have an integer value of the user input. So we can actually check whether that integer value is greater than 0 or equal to 0. And we can do that right here without passing it on to the days to units function. And just like this if conditional, we're going to do user input number greater than 0. If that's the case, we want the calculation to happen. So both of these lines will get executed only if user input number is greater than 0. And else, in our case, if it's exactly 0, we want to print a message to user you entered 0. And remember, we've got the negative numbers already covered using this condition here. So that's the one remaining. I'm just going to copy that and paste it right here. Variable is called user input number. So we'll fix that. And we're going to print out that message. So that means we don't need any validation right here. We can simply do the calculation. So to go through this logical flow of if-else or nested if-else statements, we have the first if right here. Also note the indentations for this if-else. So basically they are on the same line here, same position, and the nested if-else, or in our case elif, they're also on the same position. So again, first, that's the big validation. The first one is the user input digit in the first place? If not, we basically shut down the program. We print out a message to the user and that's it. If it is a digit, then we need additional validation. Is that digit a positive number or is it a 0? So we do that additional validation using a nested if-else statement. And basically this line gets executed only if it is a valid number and if it's a positive number. And because of that, we don't need any additional validation once the days to units function gets called. And you probably already think and notice that nested if-else statements are not the most beautiful thing in the world. They're pretty ugly actually. And especially if you have multiple of them or multiple else ifs in between, the function may actually end up looking pretty bad. So it's not recommended to have multiple levels of these nested if-else statements in your code to basically just keep it clean. But as I said, you will encounter it a lot in programs, in application code, because sometimes you just have to write it like this. Another thing I want to show you here is something called a try except in Python. So right here, as you see, we're validating user input, right? And then we're executing this part of code only if that condition is true. What if we had logic here where there were multiple places where something could go wrong? Let's say a function execution could basically just blow up because of a wrong input, or even as an example, maybe this isDigit doesn't actually cover all the use cases. So maybe there's a value that user can input that will still blow up our program. So instead of checking each such possible scenario using if statements and then doing the actual calculation once all those things have been validated, what we can do instead is basically tell Python something like try executing this part of code here, and if something goes wrong, so if any line, any function call, or any logic execution fails, we want to catch that error and we want to control what happens with that error ourselves programmatically. And then catch logic will be except, and we're going to specify what type of value we want to catch basically using this block. And the name of that error type is actually what we saw in the output when we provided some text and a float, which is value error. So that's the error that we want to catch basically. So again, we tell Python, you know what, try to execute this block of code here. And if one of those lines in that code results into a value error, then instead of just crashing the program, basically catch that error and print out a friendly message to a user. So let's actually try this out. And note that try doesn't have any validation, unlike if statement. So when I enter some text here, int function will actually be called with some text and it will result in a value error, and this block will then handle that error. So I'm going to enter and you see that your input is not a valid number, message got printed. And the same will work for a float number that also doesn't convert to integer, and for a proper integer value, it will work fine. And again, difference between if-else statement and using try except is that you can cover multiple such errors with this whole try except block, right? So you don't have to do the validation specifically, and that is especially useful for cases where you can't really validate something using if condition, right? If there's a chance that you might miss something in that condition check. So basically you just say, you know what, just try to execute with whatever value, and if error happens, then I still got it covered. And an obvious difference between this if-else is that here nothing actually crashes the program. The program will still work, it's just a nonsense value with 0 days, right? And as you see here, we have specified an error type, but with try except, what you can also do is you can basically say, you know what, I want to cover any type of error. I don't care if it's a value error or some other type of error. Let me handle any type of error. In this case, you can basically just leave it without a specific type. You get a warning though that it's too general. However, this would work and you will be covering all the error cases with it. But we can go back to our value error and know that in many programming languages, this is actually called a try catch. So except is actually pretty specific for Python. I personally think try catch makes more sense because you're catching any error that may happen right here and then basically handling it in the catch block. So if you happen to hear or see try catch in other programming languages, note that this is the same thing as try except in Python. One thing that we're missing because we converted that if statement into try except is now we need to validate the negative numbers again, because negative numbers will not cause an error in our application. So they're not covered by this except block here. So let's add back our previous else. block. And again, if neither of these are true, it means automatically would mean that it is a negative number. So let's print that message for a user. Enter negative number. No conversion for you. So now we got all the cases covered again. So let's try that out. -10, and there you go. Now, there is one minor problem with our application, and that is we can only use it once. So basically, whenever we type in a value, it either calculates it or gives us a message that we provided an invalid value, then the program basically exits. So if we want to do a calculation for another value, then we have to restart the application, provide it a value, and then do the same. So that's not very convenient if we want to use that program to basically calculate a number of hours for many different values. So basically we want to keep feeding it some different values for calculation because we don't want to restart the application over and over again. So how can we actually make the program continue after it's calculated the first value? So we want the program to basically just keep running and accepting our values. So how do we do that? And we can implement the logic using something called while loop. The concept of loops in programming is basically you do the same thing. So the same logic gets executed multiple times in a loop. And how many times that logic gets executed is basically defined in the condition of that loop. And the condition could be it should run 10 times, or condition could also be it should run until some specific event happens in the application. And conditions, you already know from if-else statement, conditions are basically logic that gives you either true or false. So condition is checking some logic and then giving you a result which is either true or false. So now the question is, how many times do we want this application to run? In our case, let's say we want to run indefinitely, right? Until we actually stop it from here, until we kill the program. So it means the condition for that should always be true. And for our application, we're going to use a while loop, which is one type of a loop, and very simple syntax while. And while, just like if, actually takes a condition. This is going to be the condition for the loop. So basically we want to tell the while loop how many times it should run the logic coming after it. And again, you know our familiar indentation. These two lines should execute in a loop over and over again with some condition right here. So how many times do we want the program to execute in our specific case? Well, we want the program to run indefinitely until we actually stop it from here, right? From our editor. So that means that condition of the loop that decides whether the next lines should get executed or not, in our case, should always be true. Because if it's false, then the loop will stop, right? No execution anymore. So how can we make sure it's always true? We just write true right here. And you remember I told you that true and false in programming languages have their own data types. Well, they are also reserved words. Even though this is just text representation, basically, you see the highlighting here, just like for these other words, because Python knows this is a Boolean value of true. And note that, again, specifically for Python, we actually write true with capital T, unlike in other programming languages. So this will basically be just a string. So Python doesn't know what to do with it, but it recognizes true with capital T. So we're telling our loop, our while loop, the condition is always true. So basically run these two lines indefinitely because the condition will never change. It's always going to be true. And the syntax is probably already familiar to you. We have the keyword, just like if or try. We can actually compare the syntax to the if statement. So we have the while keyword here, then we have the condition. So this is the same type of condition as this one right here. It's just that with us is basically fixed true value. Here it could be true or it could be false based on the condition. And then we have the colon, and then we have the indentation for the next lines. So all of these belong to the while loop. So that's basically it. We can now execute the application and see that our program runs indefinitely. So this is the first one. Let's say we enter 10. Awesome. We have a result, and then we have again the next execution where it's asking for our input again. And we can do -10. Now it's telling us we provided negative value, but we can enter the value again. Let's enter some invalid value that should be handled by this value error block. Execute. It's not a valid number, and application basically continues. So again, as you see, if you have an application that should continue running and basically get user input over and over again, you don't want that application to be crashed at some point by some bad input. You want to catch and handle every type of input so that your application continues to run. And if we want to stop it, we can basically just shut it off here. And process finished. Now we can do one optimization in our program. And this would be to allow users themselves to stop the application using some specific input value. So for example, when they type in exit, for example, the application should stop only for that specific word. So it shouldn't run anymore. So how can we do that? So basically, instead of having a condition that is always true, we want a condition that says if the user did not input word exit, then continue running the program. If user entered exit, then basically just stop it, right? So we need to change our condition right here. So here we want user input is not exit, right? So user input is not exit. Now we didn't learn how to check for not equals something, right? We have check for equality. So we check whether input number equals 0 or if it's greater than or smaller than. However, we didn't learn how to check for not equals. Not equals in programming, and this is not specific for Python, is expressed like this. So instead of two equation signs, we have an exclamation mark and equals. And if we want to compare it to a string, obviously we type that string. In our case, it's exit. So basically this condition tells our while loop, while user input is not exit, continue running the program. So while this is true, basically just keep moving on. But if user enters exit, this will not be true anymore. It will be false. So loop will basically break and application will end. Now you see that we have a warning on this user input that we're using here. And if I hover over it, you see a message that says name user input can be undefined. So it's not always undefined, but it can be. And here I want to mention again that PyCharm, because it's an intelligent editor, can give you actually this warning when otherwise in a simple or normal code editor, you probably wouldn't get such a warning. So again, it helps you in avoiding some of the mistakes that you might accidentally make when writing code. So basically it detects the errors or possible errors for you and tells you to fix it. So again, this kind of intelligent warnings and error messages can be a lot of help when programming an application. And now let's fix that warning. So what's that all about? The problem is on the very, very first run of this while loop, user input variable itself will not exist. Why? Because we're creating that user input variable on this line first. So our application will basically complain because when our while loop runs for the first time, it will not be able to find user input variable. Let's actually try that. And as you see, user input is not defined. So we need to create that user input variable before the first execution of the loop. So right here, we're going to create user input. So we're going to create this user input variable before the while loop's first run. And it doesn't really matter what the value of that user input variable will be, because what matters is the variable exists. So the value is basically just empty. And as long as it's not exit, the loop will start running and our application will get executed. So again, to go through the flow of this, we're creating a user input variable. Then we're making sure it's not exit. If it's not, this line will get executed. So we get the input from the user. That's going to be our first input. And then we call validate and execute function that basically does all the checks and execution. So that's going to be the first run of that loop. On the second run of the loop, the condition will get re-evaluated. So now the user input is what the user provided. So again, Python will check, is the user input exit? No. Cool, let's execute the program. Again, user will have to enter another value, and then that value will get re-evaluated. So note that after each time that this block of code has run and executed, every single value that user will give as an input will be evaluated over and over again in that condition. And while user input is something else than exit, it will run the program. If it is exit, then the loop will break. So let's actually test that. So this is our first message and our first input. Let's do 10. It got calculated. Let's do minus. Again, calculated, and we can do that over and over and over again. And now let's actually enter exit and let's see what happens. And as you see, the process finished with exit code. So our application actually stopped because this condition was not true anymore. It was false because we entered exit. So that's how we can allow users to finish the application. And two takeaways here. One is a conditional in a loop. And the second one is a negative equals check for values. Great, so now we have our application that basically allows input multiple times and can be terminated with exit input. Now, what if I wanted to calculate number of hours for several days, but I didn't want to basically just pass it on one after another, because that's just too much effort for me. So let's say I wanted to give it 10 different values, but I don't want to type it in 10 times, right? I want that application to basically do the whole calculation for all those 10 values, but I just want to enter that list once instead of entering each value separately. So in this part, we're going to learn another data type in Python called list. So till now, we have learned several data types like strings, for example, as well as integers and float numbers and Boolean true or false. And list is just another data type, and the syntax for list is using square brackets. And inside the square brackets, we have a list of elements, and those elements can again be either strings, numbers, or Boolean values. In our case, we want to provide our application with a list of number of days, right? So we're going to have a list of integers like this. And you can have as many values inside the list as you want. And these are going to be comma separated, and the syntax will look like this. But again, as I said, you can have a list of strings, list of booleans, etc. So as I mentioned, we want to let user basically provide input as a list instead of those individual values one at a time. So I'm going to copy this. Let's clean this up. And let's actually see what happens if I just input that list as a value right here and enter. You see, program doesn't recognize that as a valid number, obviously, because we have the check, and causes a value error. That's why we get your input is not a valid number, don't ruin my program message right here. So we want to change that and make our program actually accept that as a valid input. So how do we actually implement it? And let's go through this logic theoretically first before we start implementing it. What we need here is that we want to read this list and we want to do validation and execution for each value one at a time. So that means that validate and execute function needs to be called for each value in that list, right? So basically this function or all this logic needs to be executed for each element. Now, how do we get the individual elements of the list? So you remember the definition of a loop? Loop is basically executing same function with the same logic multiple times, and the number of times basically depends on the condition, right? Here we have a condition for while loop and a condition for executing the same logic for each of those elements is going to be the number of elements in that list, right? So we want to execute the logic as many times as we have elements in the list. And for that, we have another type of loop called for loop. And basically we want to execute validate and execute function using a for loop. The syntax for loop is a little bit different. First of all, we have for keyword, just like for while. Then we have the element as a variable. So we can call that number of days. So this variable basically represents each of those elements in the list. And then we have in, which is again a keyword of Python. So for in basically puts together the for loop logic in Python, so Python knows what we are trying to execute. And finally, we need the list that we are executing this loop on. And our list is our user input. And that's our for loop. However, again, you remember the indentation. The logic that for loop executes needs to be indented. So it should belong to for loop. So now we can read that for loop statement as follows. For each element which we decide to call number of days in a list called user input, we want to execute this logic. Exactly what I said before. So for each element in this user input list, we want to execute validate and execute function. We don't have a condition written here like we did in while loop or if statement. So the condition is basically implicit, right? The condition says however many elements there are in this list, that many times that function or that block of code here will get executed. So if I provide 5 elements, it will be executed 5 times. If I provide 10 elements, it will be executed 10 times. And that's exactly what we want. However, there are still a couple of things we need to do for this application to work properly. First of all, validate and execute function still uses user input right here. So instead, we want it to use the individual values of the user input because now it's going to be a list and not a number. So this element, we can actually call it num of days element. this value should be used here instead, right? So we're going to use that element instead of the whole user input list and paste it here. So that fixes the first problem. And the second one is, as you know, user input is always a string. So even if we provide a list of days, it is still going to be considered as a string. So we need something similar to this right here. So the list of numbers that are provided as input needs to be converted in a list in Python. And we can actually do that in a convenient way using user input.split. And split is a function that will take user input as a parameter and will give us a list data type. So split function basically will return a list of all those input values. And again, note the syntax of executing the split function. We're not just calling a split function like this with user input as parameter. Instead, we are basically calling it on user input. And I'm going to explain more about this type of functions in Python later. But for now, let's actually execute this application and see what happens. So first of all, how am I going to provide a list to this application so that user input.split can actually convert it into a proper list in Python? And the way I should provide the values are list of values with spaces between them. So basically like that. So why spaces? How come it's not a comma or something else? The reason is because split function by default splits that provided list on spaces and then creates a list value out of them. So that's the default behavior of split. However, we can override that behavior and we can decide, you know what? We want the input to be a list of numbers that are comma separated instead of space separated. So what we can do is right here, we can do split on a comma. So that's what our split function here will do. And now if I re-execute it, and I can do commas now, 40, 55. So that's going to be user input, and split with comma should convert it into a list value in Python. So let's execute it. And as you see, it worked fine. We have a calculation for each of those values. Now let's actually play around with this. And let's say we provide a list with some values, and somewhere in between we decide to add a text and then maybe a float. So let's see what happens now. And you see that for those two valid numbers, the calculation was done properly. And for the other two, basically the validation kicked in and it says that these are invalid numbers. However, again, our application ran without any problems, and we can even provide another input. So now let's actually do 20, maybe a Boolean even, and a negative number. And execute. And you see that for 20, the number of hours got calculated. True is obviously not a valid number, and minus 100 is a negative number. So everything works perfect, validations in place, and we can provide a list here now. And as a final optimization, we can actually change this message here that says, hey user, enter number of days as a comma separated list, and I will convert it to hours. So now we can provide either just one value and it works fine, or we can provide multiple values as a list. And again, if we want to see how that list actually looks like and check the type that it has in Python, let's actually print it. So first I'm gonna print type of user input dot split. And then I'm just gonna print that list itself. So let's execute and let's provide some values. And here you see this is the classed list, so basically the data type list. And that's how our list looks like. So we have these square brackets here and each element inside as a string because we have the quotes here. And later our application then transforms it or tries to transform it into an integer. And you also see there are some additional spaces here because that's how we entered the values. So basically the split splits the values on comma, so this space also becomes part of that element. So to fix that leading space in each value, we can basically just add a space here. So it will split on comma and space. And let's test it out. And there you go, we have our values without the space before them. So you saw an example of when we actually need to use list data types. In this example, we wanted to allow users to basically just input multiple values at once as a list. But obviously this is just one of the use cases for a list and one of the specific examples. Because throughout the application, you can create lists and you can use the elements of that list in another function. So you can use it for multiple use cases. And just to show you some basic syntax of how to create lists within your code inside your application, so how to initiate it and then how to use that list, I will show you the examples here. So basically to create a list in your code, you would use that syntax that I showed you earlier with square brackets. And inside that you would have a list of elements. And this could be strings. So it could be, for example, names of month, let's say, like this. And then we would have to assign it to a variable, right? Again, just like we did for strings or integers or other data types. So we can call it my list. And this will give us a list with 3 string values inside. And once you have created a list, you can then use it to read the values from the list, right? So basically to get the individual values, elements out of that list. So for example, if we wanted to print out the first element of my list, then we would access that using my list and then following syntax with, again, square brackets and then index number of the element, which is starting from 0. So this is the first element with index 0. This is the element with index 1, index 2, and so on, right? So it could be confusing because it starts with 0, not with 1, but that's how the specific element of a list can be accessed, right? So if I wanted the March value here, the third element, then I would just type in index 2. And this is a syntax of getting elements from a list if I just want specific values and not each element one by one as we had in this example, right? So one way to use a list is to basically loop through it and get one element at a time. And that's why we don't need to use index here because it gives us elements one after another. Or maybe we don't want all the elements or to do something for each element. We just want specific values from the list for different use cases. In this case, we can access them individually like this. And in addition to accessing the values from a list or basically reading the values from a list, we can also add values to a list. And we can do that by typing my list, and then on the my list we're gonna do dot and use the append function, right? So append will basically take the next element or another value basically and add it to the list of elements already in the list, right? So let's say we want to add the next month, and now if I print my list, we should actually see this here with April as a fourth element, right? So let's execute, and there you go. So first we have March here printed out, which is the third element, right? Index 2. And then we have my list append that adds fourth month name into the list. So after append, this is how my list will look like. And now again, we can access the specific element. For example, if we wanted to access the newly added element on index 3. So that's going to be the fourth element. And there you go, we have the new element printed out. And also an interesting note is what happens if we use an index here which is too high. So basically pointing an element that doesn't exist, right? So instead of 3, let's say we have 4 here. So this will point to the fifth element. And since we only have 4 elements, let's actually see what's going to happen. So I'm going to execute this. And there you go, you see an error, index error, that says a list index out of range. So every time you access or you try to access an element at an index that doesn't exist, you will get this list index out of range error. And this is actually something that may happen pretty often when working with lists if you're accessing the values like this. So this is how you work with lists, how you create them and access values in them, as well as add some values. However, note that most of the time, if you are using lists, you're going to be using them in a for loop, because most of the time you would want to do something specific for each element in the list. So this basically should give you an idea of syntax of lists and how to use them generally, and also how to use them in combination with for loops. Here I want to take a few seconds to thank JetBrains, the creators of the awesome PyCharm and IntelliJ editors, for sponsoring this complete course. Besides all the great existing products they have, they recently introduced Space, which is an all-in-one team collaboration platform covering software development, project, and team management. And the great thing about Space is that every single tool you would need in a company to collaborate and work together in a team is in one space. So you have tools for chats, blogs, planning and creating tasks, meetings, but also software development tools like version control, CI/CD, package repositories, and much more. So all of this in one platform. And in terms of productivity, the great thing is you get all the notifications in one place, like code review updates, newly created issues, new blog posts, etc. You get all of these in chats, where you can react directly in place or add them to your to-do list automatically. So I think the main value of Space isn't that it has all these tools, but rather the fact that it integrates them in such an intelligent way that it improves the team communication and productivity overall. Now let's go back to coding. Now at this point here, I want to mention a pretty minor and simple detail, but something that is also very important and useful in programming, and that is comments. So how do we write comments in Python, and why do we need, or in which cases are comments actually useful? One usage of comments is basically to give yourself some notes on your own code. So basically, if your code gets a little bit complicated and it's not really clear what the logic or the function body is doing, it could be because of bad programming, but also because the function logic is just a little too complicated. So you want to add some textual notes to that code so that you understand what's going on there, even when you look at that code days or maybe weeks after you wrote it. So for example, right here, we may want to add some notes about what this part here is doing, and comments in Python are written with this character. So for example, I want to add a note here we want to do conversion only for positive integers. And that's basically my note that summarizes all that logic right here. And it is not only useful for myself in case I forget what this complex logic actually does, but also for your team members. So if you're working in a team and your code gets really complex and it's difficult to keep an overview of different functions and variables and what all these things do, you can basically add these comments as notes to your team members so they can also understand what you thought or what kind of logic actually you were thinking about when writing this code. So comments is a way of communicating your thoughts and your logic on your code. So that's one use case for using comments. And the second use case, if you have a piece of code that you do not want to delete because it has some logic or it has some example that you want to keep as a reference, but you don't want that code to be executed. So basically you can comment out code so that it still stays there, but doesn't get executed. And the way to do that is just basically having this character before the line. And also note the color of the comment in the editor is gray, so it's immediately visible that these are the comments. And now these two lines will not get executed by the program, they will be ignored. But they are for your own reference in case you want to keep it there. For example, this could happen if you are unsure about the change and you don't want to delete that whole code from your application because you might actually need that eventually, so you're not sure about it. So temporarily comment the code before you permanently delete that. So these are some of the use cases of comments. Now, if you have multiple lines of code that you want to comment out, or maybe whole text that you wrote as a note. So for example, you want to comment out all these 4 lines here. Obviously, you don't want to do this in front of every line. So for multi-line comments, you can actually use the following syntax, which is 3 quotes at the beginning and at the end. And again, you see the highlighting is different here, which basically is highlighting of a string. However, it is ignored by the program and it will not be executed. As a best practice, you shouldn't have too many comments in your code because it will just add additional clutter and your code will look basically unclean. So you should use them only when needed. In this part, I'm going to show you another data type in Python called set. So what is a set? Let's start our application again. And let's say I provide here input values as a list. Let's say 20, 40, and 20 again. So basically I have duplicate values in my list. And when I execute it, I see that the program got executed for each element and I have duplicate results because I passed in the same value twice. Now, again, users, they can input any value they want, either intentionally or accidentally. This could be bad values or things that don't make any sense. So let's say we want our program to behave in a way that if user provides the same values twice or 3 times, we only want to calculate the number of hours for that value just once. So basically for this input, we want just those 2 lines and basically ignore the execution again for the same value. And you probably already guessed, that's where set data type will help us. So set is basically a list of elements, but with unique values inside. So a list data type allows duplicate values, the same value multiple times. Set does not allow duplicate values. So how do we use set instead of a list? And it's actually very easy to convert an existing list into a set. And we can do that using a function called set. And basically the parameter of our set function will be the list. So if this list here contains any duplicate values, that will be basically just filtered out when we convert it into a set. So that's how it works. And again, for demonstration, let's actually print out how set value looks like. So I'm going to print the list first so that we can compare. Then we're going to print out the set. And let's also print out the types. And I don't want to repeat this expression over and over again. So what we can do, even though this is just for demonstration, we can actually extract it into a variable, let's say list of days, like this, and we can use it everywhere we need. And this is a little bit cleaner because we don't have to repeat the same expression over and over again. And again, let's print out the type of list of days and then print out the type of a set of list of days. And again, you see that nested function calls 3 times. And this should give us some interesting value that we can compare list and sets. And just a small note here that whenever we have this nested function calls, think of the execution from inside out. So the first function that will get executed in this chain is actually the set, right? So it starts from the last function in that chain. So set function will get executed and convert that list into a set. Then type function will get executed on that resulting set value, and then print will get executed and print basically the result of the type. So the order goes from innermost function to the outer functions. So let's save it and execute. And now I'm gonna again provide a list, let's say 10, and then 45, and 30, and 10 again, and enter. And first of all, we see that 10 only got executed once and not twice. And we can also see the first one is basically value of a list. And you see the list here. The second one is a set. And you already notice the difference that list basically uses square brackets and set is represented using curly braces, right? And again, it has value of 10 just once. And again, we have the data type of a list and a set. So just to demonstrate that they are actually own separate data types. And like we saw previously with lists, we can also create sets as well as add and access values from it. So let's say an example here. For example, if you want to create a set, the syntax for that will look like this. As we already saw, again, set can have strings or numbers or booleans as its elements. Let's use the same example we use with lists. So I'm gonna just basically type in names of the month here. So let's say we have, again, January, February, March. And we're gonna assign that again to a variable. So this will give us a set that we can create ourselves, not just from the user input. And now we can access the values, the individual elements from the set, and we can also add elements to the set. However, we cannot access the individual elements of the set like we did on lists, right? You remember on lists, we used the syntax with square brackets and the index of the element. In set, we cannot actually do that. Instead, we can only access the elements of a set in a loop. So for example, in a for loop, we would write element in my set, and then we can basically print that element. So let's execute. And right here, you see all the elements printed out. And again, as I mentioned with lists also previously, most of the time when you're working with lists or sets, you're gonna want to loop through the elements because you probably would want to do some operation on individual elements or some of the elements, right? Instead of just grabbing individual 1 or 2 values from that. Now, how do we add elements to a set. Let's see that as well. We can add elements to my set using my set. So the set itself, the variable name. And then if you do dot, you see a bunch of built-in functions. Again, set has its own built-in functions, which are completely different from what list has. And it has a function called add. And here we can basically add a new element. Again, let's do April. And now we can print my set and execute. And there you go. So we have here individual elements that are printed out, and we have the new list after we added April. Now, one thing you probably already noticed when working with set, like printing its elements or adding a new element, it doesn't work in the same sequence as with a list, right? So for list, we basically had this January, February, March in this exact order. And when we added a new element, basically it got added at the end, right? As a fourth element. In set, it's not ordered. It's basically in a random order, right? So if I execute this again, rerun, you see the order changed here and here as well, right? And if I do it again, there you go. So this order and this order basically changes, right? So as you see, working with sets is actually pretty different from working with lists. So this means that set not having or not allowing duplicate values is basically just one of the differences between sets and lists. And of course, you're probably wondering, I can add elements, I can access elements. What about removing elements, right, from lists or sets? And you can do that actually the same way for both sets and lists. So for example, if we want to remove an element from a set, we can execute a built-in function called remove. And remove basically takes a parameter, which is the value itself. So let's say if we want to remove January from here, then we're gonna pass the value to remove function. And now if I print my set again, after the remove gets executed, and let's run it. And here you see the last print basically doesn't have January inside. And as I said, it works the same for lists. So let me demonstrate that as well. So on my list, which has its own set of built-in functions, one of them is remove, which in this case is called the same for both set and list. And this remove built-in function also accepts the value of the element you want to remove. And let's print it again, my list, and execute. There you go. This is a set with the syntax with curly braces, and this is a list which now doesn't have January inside because we removed it. And as you know, lists can have duplicate values. So if we have January again here, so 2 times, and we do remove January, it will actually remove the first occurrence of that value. So if I execute this, you see the first one got removed and the last one, or the second January value, is still there. So that's how you work with sets basically, and also how to remove elements from sets and lists. So at this point, I want to take time and review the functions that we have used from Python itself. So the functions that we ourselves didn't actually write, and the functions that Python basically makes available for us to use are called built-in functions. So till now we have used function print, which basically just takes some input. This could be a string, this could be a variable, this could be a number, doesn't really matter, and basically just prints it in the output console, right? In the terminal. We also saw input function that basically takes user input. Again, we can provide a parameter, which will be a message, or leave it empty. We also, in the last example, saw an example of set function, which basically takes a list and converts it into a set. And another example is int, again, takes a string as a parameter and converts it into integer. And all of these are built-in functions because Python provides them to us so that we can use it in our code. And in Python, there are a lot of very useful built-in functions for different purposes. And as I mentioned, most of these functions basically accept a parameter and then do something with that parameter, that input that we provide that function, and give us an output. Again, print basically provides something here and gives us the output in the output window here. In input, we can provide some message that will again print an input here, and the rest of them are giving value inside the code without displaying anything. So instead, we can provide a list and the same way a parameter here, which is logical because the purpose of a function usually is to take some input like this as a parameter, do something with that input, and give us an output from that parameter. And we have created our own functions that also take some input and give back some output like this. And in addition to built-in functions that are called like this and our own functions, we have also used a third type of functions, which is called directly on a value, right? And this is an example of that. So basically, directly on a value, this could be a variable, but also the string representation of that itself. So if I had a string like that, so basically directly on that value, call a function like this. And these are also built-in functions because Python makes them available to us. Other than the syntax, there is one major difference between this type of functions that are called directly like that and the functions that are called on the value itself. And the main difference is that each data type has its own set of functions that can be executed like this. So again, let's take example of a string. And if I do dot here, you see the IDE, PyCharm, basically gives me a list of all the functions, again, built-in functions in Python, but functions that I can execute on a string value. And again, you see split is digit. This is the one that we used in one of our previous examples that basically checks if that string is a representation of a digit or just a regular string. And as you see, lots of different functions. So all of these are provided by Python to do different stuff, like turn the string literal to uppercase or replace a letter, for example, in that string, and so on. But the main point here is that those functions are only for string. But as I said, each data type has its own list of functions that can be called on that data type. So for a demonstration, let's take a list. And if I do dot here, again, you see a list of functions that I can execute specifically on list values. And there are lots of things that you can do with lists, like add elements to it, remove elements from it, sort the list, copy, and so on. So that's basically a major difference between this type of functions and functions that can be executed on specific data type values. But the concept is the same here. You also have a function that gets a parameter, an input, and gives you an output. And the parameter for this type of functions is actually the value that we're calling that function on. So this string here, 2, 3, is going to be parameter of the split. And in addition to that, we can also provide additional parameters. For example, for split, you saw here that we were able to add a comma space to basically tell the split function on which character to split that text. So that was function comparisons in a nutshell. In this part, we're going to learn a new data type in Python called a dictionary. And we're going to do that by modifying our application and modifying how users can actually input the values. Now, our program currently takes the number of days and turns it into a number of hours. What if we wanted to make our program a little bit more advanced, a little fancier, and basically allow users to also decide what units it should be converted to? So user gives us the number of days and tells us whether to convert it into hours or minutes. So instead of the whole list, now we're gonna get just number of days and the conversion units. And this change may be a little bit complex in terms of syntax, so I will try to explain everything step by step. So the first thing we need to do is adjust how we get input from the user. So now we want the user to be able to give us the number of days and units in one input. So first of all, I'm going to adjust the text here, enter number of days, and conversion unit. Now there are a lot of different ways we can allow a user to do that, but what we want to do is something like this as an input. So basically number of days, colon, and minutes, or number of days and hours. Again, this is our own decision. We decide how the user input should look like, but this should be a nice way of providing both of those values, basically colon separated. So instead of a list, we're going to have a single input with two values that are separated by a colon. So on the next line, I'm going to change this split here into a colon, and this will give us user input, this whole value split into two values as a list. This is going to be day and days and unit. So list with these two values. And let's actually get rid of this for loop because we're not iterating through a list of numbers anymore. And to begin with, let's just print out the output or the result of days and unit variable. So I'm gonna refresh and let's do 2 hours and enter. And this is what we get. So basically splitting this string on colon will give us a list with elements 20 and hours. And note that 20 is still a string, right? Because that's how we get the input. And now from those two values, we're going to create a value of a data type called dictionary. So in Python, we have another data type called the dictionary, which basically looks like this. So you have curly braces, just like we had for a set. And inside, we have key value pairs. So we don't have just single elements like this, but rather we have key value pairs. So key, in our case, is days, and the value of that key, in our case, would be 20. And then comma separated, another value would be unit, and a string hours. So basically, this is the syntax of a dictionary. And obviously the difference between a list and a dictionary is that we have descriptions for each of our values represented as key value pairs. So we want to create this construct right here from those two values. And since this is a data type, we can create a value and assign it to a variable of that data type. So let's call it days and unit dictionary equals, and obviously we don't want those values to be hard-coded here. We want to get it from the list. Now, how do we access an element of a list? How do we grab the first value, which is 20, out of that list? And to do that, there's a syntax to access the elements in the list name, and then you have square brackets and index of the element, which, if you remember, you already learned in the section of lists. So again, days of unit list is this one right here. And with index 0, we are accessing the first element. Index 1 is the second element, and so on. And index is basically just location. This is location 0, location 1, and so on. So this will give us the first value, and obviously the second value is going to be with the same syntax with index 1. And let's actually print that one out as well, so that we see the results. Restart the application. Let's do 20 hours. So again, this is our list, 20 hours as 2 separate values. And this is a dictionary that we created using those 2 values. So we have key value pairs basically. And the same way for minutes, we would end up with a dictionary that looks like this. So now we have these 2 pieces of information in one variable, and now we can give that variable to our function so that it does the validation, first of all, of the number and calculation based on the units. So on the next line, we're gonna call our validate and execute function. And as you see, we have this red line here because something is wrong. First of all, we don't have this variable called num of days element anymore because we deleted the for loop. Instead, we have days and unit dictionary. And here we're validating the integer value of the input number. And the same way we need to validate this input number here as well. So now the question is, how do we access a specific value, in this case, the value of days here, in a dictionary? Because we have to validate this value as well, because I might as well have entered text instead of this number. So the way to access values inside a dictionary is, again, using the square brackets, just like we did for list. But instead of an index 0 or index 1, we don't need to use an index because we actually have a key. So instead of index, we're gonna use the key, like days or unit. And this will give us value of 40, which will then be converted into an integer and then validated right here. So again, I'm gonna copy this for comparison. So to access an element of a list, let's say my list here, and let's do 20, 30, doesn't matter. In order to access the elements of that list, we can do that using an index. So this will basically print number 30. Again, if we had other elements here, we can do index 2, so that will print out 100. And let's actually check that. And remember, to comment out a multi-line code, we can use 3 quotes at the beginning and at the end. Let's refresh, and there you go, 100 was printed. Let's do the same with the dictionary. Let's say we have a dictionary, days, like this. And to access an element inside that dictionary, we use the square brackets, and instead of the index, like here on the list, we use the key itself. And again, I'm going to print this. And there you go, you see value 20. And I can also access unit value, and if I execute it, I see hours, and so on. And I can add any number of key value pairs in my dictionary as I want. So for example, I can add a message here, all good, and I can access that message like this. So this is how you create a dictionary, and that's how you access the values in a list or in a dictionary. So let's clean this up. Comment in our code again, like this, and get back to our code. So basically, again, this is how we access the number of days in our dictionary. And in our days to units function, we need both of those values. And we can pass in those values separately. So we already have a user input number from the dictionary, and the second value would be the unit from the dictionary. However, we have to add that second parameter to our function. So let's do that. Unit, let's call it conversion unit. So now we are passing both of these values to our function. So we have the user input number here, which is already converted into an integer, and the second one, which is the conversion unit. And now we can finish the logic in this function here. Right now we are using this hard-coded calculation to units, which is 24, and number of units, which is hard-coded hours. So first of all, I'm going to remove those two. We don't need them anymore because we get those values from the user. And now we have to substitute those two. So here we're going to check if the conversion unit is hours equals hours, then we're going to return calculation with hours. It's going to be 24, and conversion unit here. We can also hard code hours here because we know it's hours. Else if the conversion unit is minutes, then we can return calculation for minutes and a text like this. And it could also be that the conversion unit that was provided is none of those, or maybe some invalid text. And in this case, we're going to add final validation. So if it's neither hours nor minutes, then we're just going to say, you know what, unsupported unit. So basically we don't do conversions other than those two. So we just tell the user that's an unsupported unit. And now if we execute our program and enter value, there you go, we have our output. And same way, if we do 90 days to hours, we have our calculation in hours. So that's how dictionaries work. We can do one final thing here, and as usual, print out the type of our dictionary. And there you go. You see class of type dictionary here, which is another data type. And at this point, we can actually summarize all the data types that we have learned so far. So let's give us some space here. So first one was string. So basically a message or some output like this. That's our string. Then we have integers. Example of that we saw already, days. Then we have float numbers, which for example can be used for price or weight of a product, etc. We also have learned Boolean data types when we check some kind of condition, whether if it's true or not. So for example, is it a valid number? Or is the user input exit? We also learned a data type of lists. So for example, usage list of days. Like this. including duplicate values, and list data type can be used for strings as well, not only for numbers. So for example, we can have list of month, like January, doesn't really matter. We also learned a data type called set, and set basically is very similar to list, but it doesn't allow duplicate values, and its syntax is with curly braces. So the same way we can have numbers or strings or booleans or any other data types inside a set. And the last one that we learned was a dictionary. And let's take our own example, day and unit. And dictionary is basically a collection of key value pairs. And the syntax is written like this. So why do we need all these different data types? Well, depending on the use case or what exactly you are trying to achieve in the program, you're gonna need a different data type to achieve exactly that. So each data type has its own specific purpose. And throughout this days to units calculator, I try to demonstrate the purpose of each data type and when we need to use them. So these are all the data types that we learned. These are also most of the data types available in Python and the main ones that you're going to be working with. So this should give you a good foundational knowledge about data types in Python. And also note that most of these data types you will also encounter in any other programming languages, because as I said, these are the core data types and most of the programming languages actually support these data types as well. Till now, we have been writing all our code in one single file. So basically we have a project with just one Python file and we're writing all the logic inside that file. However, you can imagine that if you're writing a little bit more complex applications that have much more complex logic, so they end up having lots of functions, obviously you're gonna end up with a Python file that has hundreds of lines of code, maybe thousands of lines of code. And it's not very practical to manage all this logic and all this code in just one file. So instead, you need to structure your code and divide your logic between multiple different Python files. And you do that with modules. To give you an example, imagine a web application that has basically many features like Facebook, for example. Obviously, you can't put all the Facebook logic in one single Python file, right? You will have a structure of Facebook project with subfolders in your project which all contain multiple Python files. So you would have maybe packages for each feature, and each such feature has a lot of functionalities, so they will be all grouped then again in multiple Python files, right? So you would end up with a project with a hierarchy of folders and lots of Python files inside. Now the question is, if I have multiple Python files in my project, how do I connect them together? So for example, if I have another file here, and let's call it helper.py, and if I have some logic here, basically functions defined here, how do I use them or how do I reference them in another file? And the way it works in Python is using the concept called modules. So a module is basically a Python file that contains functions or variables that you can use in another Python file. So basically any Python file that you have in your project, both of these in this case are modules, and you can reference one module from another. So basically the idea is that you can structure your application, your program, using modules. So you can make your project modular. So in this part, we're going to create our own module in helper file, and we're going to reference that in main.python. And let's say in main.python, I only want the code that basically starts the program, right? All the functions, all the logic, I kind of want it hidden away and grouped together in a separate file. So what we're going to do is copy this entire thing. So both of these functions basically, and paste it in here. So now you already see a couple of red lines here because now the reference is obviously broken, right? So main.python obviously doesn't know anything about validate and execute function, right? It says unresolved reference. And the same way, days to unit dictionary is unresolved for helper because it doesn't know anything about main.python and the variables defined right here. So the first thing we need to do is we need to tell main.python file where to find this validate and execute function, right? We have defined it in helper Python, so that's what we need to define. How we do that is using something called an import statement. So we basically import this whole helper.py module inside main.python. And we do that very simply using import helper, right? Helper is the name of the file and therefore name of the module. And right now it's gray because we're not using it. And the way to use it is helper dot and the function name. And you see the red line disappeared. So again, what we did is we told main.python there is a helper module in this project and please import this whole module and all the functions that this module has and make it available in main.py. And then once we have that helper module, we can reference any functions if we had any variables using module name dot function. So this has to be the name. And if I hover over it, you see that PyCharm actually displays the whole path to that helper.py file. And now note that here we still have redline because this is a variable which is defined in main.py, but a helper module doesn't know anything about it. And that's an important distinction here because we imported helper module inside main. So a helper module's functions are available here, but not the other way. So in order to make this dictionary available in validate and execute function, we would need to pass it in as a variable like this, and this will work now. Now note that in main.python, we actually only need this validate and execute function. We don't need the days to units function because this function is only used by validate and execute function. So that means that we don't need to import the whole entire module inside main.py. We actually only need the validate and execute function. And this is a small example, but if you had a module with 20, 30 functions and you just needed one of them, you wouldn't need to import the whole module just for that one function. So what you could do is you can pick and choose which specific functions you want to make available inside another file or another module. And you can do that very easily using the following syntax. We say from helper, that's the module again, import, and the name of the function. Like this. And now, because we are accessing and importing that specific function, we don't need to use module name anymore. We have that function available directly. So we can delete the module reference here and we have that function available like this. So again, instead of having entire helper module with all of its functions and other stuff, we only have one specific function available here. So that means we wouldn't be able to use days to units, for example. Now we saw an example of a module that has just functions, right? However, a module can have many other stuff, for example, variables, and you can make those variables also available for another program. And that's an example here. I'm going to create a variable called user input message. And this is our user input message, and we can actually put it into a variable instead of having it defined like that. So I'm going to copy it and paste it here. So now we have the user input in a variable in another file. Again, how do we access it in main.py? In this statement at the top, we can actually import several things from a module. Right now we are importing a function. We can also import our variable, and we can do that also very easily like this. And we can use that user input message here. So basically, if you have, again, 20 functions and variables from a module and you just need maybe 5 of them, you can import them individually like this. Just basically just list the names of functions and variables. What you can also do is import all. This is what this asterisk sign represents. So we're basically importing everything from the helper module. Again, this is kind of a waste if you just need a couple of functions and variables from that module and not the entire thing. However, with this syntax, you can import everything. And now you may be wondering, what is the difference between importing everything from the module and importing the whole module? Because in both cases, you have everything in the module available. The difference is in the syntax. Because note that if we use this from import statement, you don't need to use name of the module every time you're accessing something defined in that module, right? So we don't need to do helper.function name or helper.variable name. Whereas if we imported the module like this, you see we have red lines because we would need to do helper dot or module name dot whenever we use something from the module. Now this could be a matter of taste, so basically which one you want to use. I personally think that this is the most efficient and also cleaner way of using specific functions, variables, etc. defined in a module. And as a side note, the things that are defined in a module that you can use basically in another file are called definitions. So all of those 3 elements here are definitions of a module, and you can use any of those definitions in a file where you import that module. What you can also do when importing a module is you can rename that module basically to whatever you want. So if the name of the module is too long or you just want to use a different name, you can do as and then basically write a name, whatever you want, like H, for example. And then obviously you need to use that new name everywhere you access functions or variables of that module. So basically how you import a module and whether you rename it is a matter of taste, basically how you want to do that in your code. However, I think that importing specific elements from a module like this is the most efficient and also cleanest way to do that. So we saw how to create our own module and use it in another file. So basically, if you had 100 Python files here, with each one of them having their own functions and variables, you can cross-reference them from each other using the import statement very easily. Now, in addition to creating your own modules, we can actually use modules that Python itself already includes. So just like we used some functions that Python gives us out of the box, like inputs or int. So basically all of those, the same way Python also gives us modules for different scenarios so that we don't have to write this logic ourselves. And there are a lot of useful modules that Python actually includes. For example, math module for mathematical operations, its own module for working with dates or date times, module for working with specific files, and so on. So basically, for many different use cases, Python already gives you ready modules, and these modules will then contain multiple functions and variables for that specific use case. Again, if we take an example of a date, so if you have an application that works with dates and times, you have this module from a Python that gives you a bunch of useful functions for working with dates. And again, this means you don't have to write this logic yourself, but rather use the existing one. So to give you some examples of modules that Python provides us with, for example, if you want to work with the operating system, there is an OS module. So we can print out, we can get the name of the OS, for example. And I'm going to comment all this out and run. And you see the name of the OS. Another useful module Python offers is logging. So if you want to use logging in your application, the logging module gives you different functions to log an error message or warning, etc., as well as basically just configure how the logging will look like. Again, to see an example. Again, it may look a little bit complex here, but essentially just using the name of the module and then functions that it gives you. Obviously, you need to know the functions and you need to know how to use them, and you can get that information from documentation. Or if you're using PyCharm, it actually gives you all the information about these functions and the module if you just hover on it. So you don't even need to Google or check out the documentation. And basically we're creating a logger and we're logging an error message. So if I execute this now, and here you see the output of the logger, error happened in the app. And logging in application is actually a very important feature. So that's why logging module is available by default in Python. And a use case in our application would be right here. If an error happened, for example, instead of using a print, basically just log an error. So these were just some basic examples, but as I said, Python comes with lots of very useful modules that you can use in your applications for different use cases. And that, of course, makes your work easier because you can just use the logic instead of having to write it yourself. And the modules that are part of Python, so that you can import them like this directly, are called built-in modules. We learned about built-in functions. So these are the functions that Python makes available to us directly, and they are built-in modules that we get from Python. And by the way, if you're wondering where this module actually comes from, so where is the physical location on our machine of where this module files actually live, if you're using PyCharm, you can actually hover over it and hold down a control key, or if you're on Mac, command key, and click inside. You see the file opens up, which is the module, the logging module. Since I said module is basically just a Python file that has multiple functions, variables, etc. available. And you see right here on this top line, the whole path for that Python file. So that's the location of that module file locally on my computer. And inside this Python file, basically, you again have Python code. And if we look for get logger function here, like this, right here, you will find the definition of that function, right? So somebody implemented this function and called it get logger. And this is basically the logic, all the things that get executed behind the scenes. And you as a user of Python basically can use the name of the function and write your own programs with it. And let's also look for error. And there you go, we have error function as well right here. And obviously this is a more complex code here than what we write, but just to give you an idea that this is actually a file on your machine that comes with the Python version that you install locally, and all the functions are defined already there by Python developers, and you can just use them like this without worrying about how the logic is actually implemented. And another interesting thing is if I click here in this Python 3.9, like this, logging is basically one module that we used, and here you will see the complete list of all the built-in modules that you get from Python. So some of them are folders like logging, for example, email, and a bunch of other stuff. And the operating system module, for example, that we used is a Python file that you can find right here. So these are the built-in modules. So now that we know what built-in modules are and how to use them, let's actually see a realistic example and also write a little more interesting application using built-in module. So what I'm going to do is in my Python project, I'm going to create a new file, and I'm going to call this time-till-deadline.py. And we're going to write an application that basically accepts a user input of a goal and a date, like a deadline date. And then we're going to print out back to the user how much time it is remaining till that deadline. And that deadline will be a date, right? Some date in the future. So that means that we're going to be working with dates. And in order to work with dates, we are going to need Python's built-in module that allows us to call functions and do some processing and stuff on date values. And that module is called datetime. So import datetime. So let's have that import statement right there, and we're going to use it in our program. So the first thing we want to do is let the user give us an input about their goal and a date or deadline for that goal. So let's do that first. We already know how to ask for user input with a message. So we're gonna say enter your goal with a deadline separated by colon. And we also know this already. Basically, what we want to do is user to be able to enter their goal, like learn Python, colon, and a date. And let's say, again, this is totally up to us to decide. We're the ones basically setting the rules here. So let's say we want the date to be entered in the following format: day, month, and a full year, like this. So that's the format that we're looking for. And this is how user should input the value. Otherwise, with a different format, it's not going to work. So we're going to save that input value into a variable. Let's call it user input. So we have the user input. Let's do the split again on a colon. Remember, we have this whole thing as a string, as one string. So we want to split it into two parts. So we have the goal here and the deadline. And this will give us a list with those two values. And let's call it input list. And now from that list, we can actually extract or get those individual values using a list syntax. So accessing the elements from a list, which is what we learned already using an index, right? So we have input list index 0, which is going to give us learn Python. And let's save it as a goal variable. And let's create another variable, which is going to be date. Let's call it deadline. And this will be the second value in our list. Now, let's actually print this out. Print this whole list out. And now note that we are actually in a different file. We're not in the main.py anymore. And we don't want to execute main Python file. Instead, we want to execute this one right here. We basically just want to ignore everything else in this project. So how do I go from main to this file execution? Very easy. In this editor, just do right click and you see here run time till deadline. And I'm going to execute this. Everything else is ignored in the project. We are basically just working on this one right here. So enter your goal with a deadline separated by colon. Let's do that. I'm going to do learn Python colon, and then let's enter some date and enter. And this is the output. So we basically split that into two values and put it in a list right here. And very important to note here that both of these elements in this list are strings, because again, user input is always interpreted as strings. So this was a string and it was split into two strings, which are learn Python and this date here. However, we don't want date or deadline as a string, we want deadline as a date. And exactly for that functionality, we need this datetime module, because we don't want to implement it ourselves. We want Python to give us a ready function from a module that will basically just let us convert this string into a date value. And converting string to date is just one example usage of datetime module, but you can use this module to work with dates generally, like creating new dates, formatting the dates, updating the value, etc. And we're gonna see some of those examples in this section. Now, if you're learning this type of thing alone, you don't have me basically teaching you and giving you an example. The way you would do that is you would basically research and maybe Google how this is done in Python, and you would basically see some examples of using this datetime and what the name of this function is and how to use that. As well as each module has its own documentation page where you can look up the syntax and usage examples, because obviously you're not gonna know how to do that by yourself. So the way we convert a string into a date using this datetime module is on this datetime module, if I type in dot, I will see a list of all the definitions that datetime module gives me, right? So I have date, datetime, time, etc. The one that we need is datetime, because the function that we need for conversion is inside that definition. And don't be confused here, because we have datetime twice here. The first one is a module and the second one is a definition in that module. And we can actually check that as well. So if I jump into this datetime module, and inside that, if I look for datetime again, so right here you see this datetime definition, and on that datetime definition we have now functions that we can use. And as you see, this is not a function or a variable. It says class here, which is another concept in programming we're gonna see later. So just for now, think about this as a container of functions and variables inside that module. And that's why we have to access it like this. And then on that datetime definition, this class, we now have functions that we can use to do the conversion. So the function we need is called str, so string p time. And this function will take a string representation of a date and will convert it into a date format. So our string representation is deadline, and we need to pass in the second parameter, because remember I said we basically decided that the date should be entered like this, with points and a full year here. And as you know, there are lots of different formats and types for dates, right? Depending on a country or a language, or even within that language, we basically have multiple different formats, right? We have formats like this, or we could also have a shorter version of the year, etc. So we need to define here the format that we want Python, or this method here, to use when converting this string into a date. Again, because there are so many different formats available. So what we have here is a day, then we have a dot, then we have a month, again a dot, and then we have an year. So this is kind of a main structure of a format. However, formats for dates have their own specific syntax, and this is actually for all programming languages. So what we need to do is put this percentage sign in front of every letter. So again, we have day, month, year. And there is one more thing about this format. This format right here matches this date. However, we want the full date, not just the last two. And the format for that would be a capital Y. Again, this is something that you would look up in the documentation of the module instead of knowing it by heart, but just know that these type of formats are used when working with dates, and this is not specific to Python. You will actually see something very similar in all the other different programming languages. And that will do exactly what we want. It will take this date here and give us a proper date format from it. Let's actually test this. So I'm going to print this first. And I'm also going to print a type, a data type of that value. So let's execute. I'm actually going to copy that so I don't have to retype it over and over again, and enter. And here you see we printed, first of all, the date, not a string. And now this looks like a proper date and not a string anymore. Note the change in the format. Plus we have these zeros here, which represent hours, minutes, and seconds. We didn't set any of those, so these are all 0. And we have the date time type. Again, note date time for a module name and date time of the class name. So this is the type of our converted date. And the reason why we needed to convert that string into a date is because we want to calculate how many days or how many hours are remaining until the deadline from now, starting from today. And to do that calculation, we need to have date type because we can't do that on a string. Great, so now we have our deadline represented as a date. So let's actually assign this to a variable. Let's say deadline date, like this, and remove this. And now we need to do a calculation. How many days from now till the deadline? We already have the deadline. We need now. Again, now is, or today is also a date. And since we have this module, datetime, we can also assume that this module will give us some function to tell us the date of today. And if I do datetime, again, datetime class, and today, you see that we have this function available, and this will basically give us the date of today. So depending obviously when you execute this program, it will give you always the current date. So let's print it. Today for me it's 7th of February. So if I execute it now, I'm gonna enter this, and today is 7th of February for me. So if I execute this, let's actually comment this out. Here I have the date for today, which is 7th of February, plus the exact time it is now, but we don't care about the hours and minutes and seconds. We just care about the day. So that means we already have deadline and we have today. Let's also add it to a variable. Like this. And now we can actually do the calculation. Calculation is super easy. We just say deadline date minus today date. And this will actually give us the difference between, or time difference between today and the deadline date in the future. Again, let's actually try this out. And you see that, so this is 12th of August. For me, today it's 7th of February. So the program calculated that there are 185 days until that time, plus how many hours, minutes, seconds, and milliseconds. So that was a pretty easy calculation. Now, what we want to do is tell the user some kind of message. And we want the message to be, dear user, the time remaining until the deadline for your goal, whatever the goal was, is this. So let's actually put that text and message together and print it back to the user. So first I'm going to save it into a variable. Let's call it time till and the message. Dear user, time remaining for your goal. And here we want to print what the goal actually is. And you remember how we format a string when we want to use a variable. We put an F here, and in curly braces now we can use variables or numbers or some other expressions which are not string. So first of all, we're printing back the goal. So time remaining for your goal, whatever goal they entered, is time till. And let's execute our program. And let's give it some other value like this and enter. And here we have our message. Dear user, time remaining for your goal, learn Python, is 132 days and this many hours, minutes, etc. Now let's say we don't care about this whole thing here. We just want to know how many days are remaining. So how do we get rid of this part here? Again, very easy. And the time till, if I do dot here, I get a list of suggestions for functions or variables that I have available. And one of them is days, as you see here. So if I click here and save, and I'm gonna reuse this input because I don't want to type. And as you see, we got rid of this whole thing here and we just have days. And let's actually write days. And there you go. We have a cleaner output now for our user. And finally, what if the deadline was just a couple of days in the future and the user wanted to know how many hours are remaining till that deadline? We can do that by getting rid of these days and again, type in dot, and we have something called total seconds here, which gives us the time difference in total seconds. And now we can reverse engineer and calculate the number of hours from this total seconds, which is pretty easy, like this. Calculate minutes and then calculate hours. And I'm gonna execute this again. And here you see the number of hours with a decimal precision. So we have 4,450 hours, point some fraction number here. Again, we want to get rid of this extra stuff. And as you see from the syntax, it is actually a float number with a dot here. So what we could do is basically convert this whole thing, this float number, into an integer. So convert this whole thing into an integer using int function. And we need this whole calculation here inside the int function. And let's execute it again. Learn Python. And let's choose a date which is near. And there you go, we have a whole number, 57, again, cleaner output. And as a code optimization, we could take this whole thing out into a variable and call it hours till to make our code a little bit cleaner. So now we have the whole program that takes user input and basically prints back to them how many hours are remaining till the deadline for their goal. And for this program, we used a datetime module, a built-in datetime module from Python, and we also learned a new data type, which is datetime. And as we learned from the module section, we can actually optimize the import of the module because obviously we're just using the datetime definition and nothing else from that module. So what we could do is from datetime module import datetime definition, which is a class in this case. So now you don't need to use the module name. So let's get rid of those. And this could make the code cleaner as well as make the import more efficient because we're not importing the whole module, even though we just need one definition from there. When you install Python, it comes with a set of modules that are built into Python. However, there are many more modules for other different use cases like web development or data science and machine learning, etc., that are not part of that installation. And these are basically external modules, not built-in modules, that you have to install as you need. And this makes sense because the built-in modules are the ones that most of Python programs will probably need. And depending on what specifically you are doing with your program, whether you are developing a web application or creating some machine learning program, you can then add and install them as you need. And there are hundreds of such external modules for Python out there, and obviously it wouldn't be practical to have them all on your laptop when you're just going to use maybe a handful of them, right? Now, if I need to install an additional module, for example, Django for web development, where do I find these modules and how do I install them? Python modules actually live in a module repository where you can find them, and that module repository is called PyPI. So if I look for PyPI, right here you see the Python package index. If I click inside, you can search for any module that you want to add or install additionally for your application. And here you see this word package everywhere instead of a module. So what is a package, or what is the difference between package and a module? To give you a simple comparison, module is basically a Python file like this one right here that has a name of that file, right? So we have an SSL module, or the one that we used earlier, we have this OS module, right? So module is one Python file that contains all these functions and variables that you can use. Package is a collection of modules. So if we scroll up, and logging is actually one, our example. So these are actually packages. And again, let's go to logging. So package basically contains multiple Python files. And use it in the same way you basically import the functions and definitions from the module. And as you see clearly, the difference is that package is more structured. So for example, the code is not available in just one single Python file, but is divided like this. In our case, we have two Python files, and package always has this init Python file. And this file basically differentiates a normal folder like we have right here with a bunch of Python files from an actual package with Python files. So that's the difference between modules and packages. And many external modules basically that we want to use in our projects are actually packages. So basically packages are a good way to define some hierarchy and structure for your modules and kind of group them together. So that's why you see package here as a name instead of module. So now that we know the difference, let's actually search for a package for our project. So for example, if I type here Django, you see Django packages that we can use from here. We also have NumPy, and so on. However, in programming, when working with and using these external packages, a typical example would be where you need to implement some logic. For example, you want to write a program that basically talks to AWS maybe, and you don't know exactly the name of that package, but you know what you're looking for. So in this case, instead of the exact name, you would actually type in here in the search projects box a description of what you're looking for. So let's say we're looking for an AWS API package, right? Something that will allow us to connect to the AWS API. And as you see here, we get a list of different packages for that to choose from. So basically, PyPI is a repository or storage for all of those modules and packages. And people can also publish their own libraries, like individual developers, for example. They can publish their own packages and modules there and make it available for other programmers to use. And that's one reason why a large community is so great for a programming language, because then you can make use of all these modules and packages that others in the community have developed. So for any kind of functionality you need in your application, you could imagine that there is a module or package that helps you do exactly that. Now let's say I need a Django package for my web application. So first I find the package, and now I can actually check some of the documentation for that specific package. So if I click inside, I see some description for the project, as well as documentation and some other links. Now the question is, how do I actually install this package locally so that I can use it in my project? In Python, we install packages using a package manager tool called pip. And right here on top, below the package name, you actually see a command, pip install Django. So this is actually a command that will install that package locally on my laptop. So we install packages in Python using this pip command. So what is this command, or where does it come from? Pip is a package manager for Python. And if you know any other programming language, basically the concept is the same. Every programming language has its own package manager tool. For JavaScript, it's NPM. For Java, it's Maven or Gradle. And for Python, it is pip. And one of the main tasks or usages of a package manager tool is to install external packages or libraries, or also called dependencies, for your project. So if Python needs this Django package, basically it's the job of the package manager to install that package and make available for Python. Now, where did this command come from? Do we have pip command available? Well, in Python version 3 actually, pip is packaged inside the Python. So when we installed the Python, we actually installed pip as well. So basically we're gonna copy this command, pip install Django, and we're gonna execute it actually from the terminal of PyCharm. So in PyCharm editor, we have this integrated terminal. So this is actually pretty much the same terminal as you have outside, like this. So we're gonna execute this pip install command directly in this PyCharm terminal. So I'm gonna copy it here and do pip install Django. And you see it is downloading and successfully installed Django 3.1.6. And we can actually see that package from our editor directly. If I expand these external libraries and site packages and scroll a bit down, here I have Django 3.1.6 version installed. So I see that the package is now available in my project, and to also test it, in the code I can do import and Django, and you see that PyCharm actually recognized that I have Django package locally, so it gives me that package as a suggestion. So that will basically import the whole Django package. So we can now use it in our application. Here you see PyCharm actually noticed you are using or want to use Django Web Framework. As I mentioned in the beginning, the PyCharm Professional Edition has special support for different Python web frameworks, supporting you with syntax highlighting, suggestions, database integration, and so on. So again, if you want to try it out for free for 3 months, just use my code in the video description. In the same way as we install the package, we can also uninstall packages using pip. And let's also actually demonstrate that. Pip uninstall Django. And let's confirm that. Successfully uninstalled Django. Now if in the site packages I click inside, you see that Django packages are gone. So this site packages folder got updated, Django was removed, and you also see that in the code editor now I have this red line under Django because PyCharm cannot find a module called Django. And also if I do this, obviously it won't give me any auto suggestion for that. So that's how you can use pip to install packages and also to uninstall packages for your application. Now here I want to show you another cool alternative to installing and uninstalling packages directly in the PyCharm IDE. And this is actually a feature in the latest PyCharm release. And for this, I need to switch to an early access PyCharm version. So you see here, it says PyCharm EAP, early access, to show you the feature. However, when you watch the tutorial, it probably will already be included in the latest official PyCharm version. So you should have that already. So instead of us basically finding this package in PyPI and then executing pip install commands right here, what you can do is down here you have another tab called Python packages. So if we click inside, this is a place where you have everything that you need to know about the package search, and all these features basically in one place. So for example, in order to install Django, we can just search for Django right here. And you see that when I type in the first couple of letters, I already get suggestions. So this is a list of all the packages that start with this name that are actually available in PyPI. So let's type in Django, and we see that right here. And on the right, you see the documentation of the package that you would actually see in PyPI UI. So you have that in place as well. And in addition to that, what they added is the documentation link. So this is actually the package how-to guide and the full documentation with examples, etc. So very convenient way to basically get all the information about the package, search the package, and then to install the package, we can choose the version here. So either you can leave the latest or basically select the specific version. And then once you have selected that, you can just click install. And here you see installing package. And there you go. So now in installed view here, so we just had pip and setup tools, these two things installed. And right here we have now Django in the installed packages list. And again, while you're now using the installed package or library in your code and basically want to look up some examples or you want to check some documentation, right? You go back to the package, click inside, and you have link to documentation and the package information as well. And also just by looking at this list, you know which versions of which packages you have installed. So I think it's a really cool way to manage all your packages, to install packages. And for example, if you want to uninstall packages from your project, then again, just clicking to that specific package right here, you can just delete it and it will be removed from your application. Like this, and no Django anymore here. So a very cool addition to PyCharm, because this will be very convenient to work with the packages. So now I will switch back to my other editor again and continue from there. So basically I have just cleaned up my Python project. We have this main.py, which is empty, and we're going to write an application that will read a spreadsheet file from our local file system. It will read some information from that spreadsheet file and do something with that data. And this could be a very useful use case if you're working with lots of files and you want to do some data processing in those files and you don't want to do that manually. By automating or writing a program in Python that basically can do anything in a file or across multiple files. So let's see exactly what we are going to be doing with this program. So first of all, we're going to have an input file, a spreadsheet file that we're going to be working with, and that spreadsheet will look like this. It's called inventory. That's how it's going to look like. So basically this file simulates something that many companies would have and employees of that company would be working with. So we have this list of product numbers, inventory for each product, price for the product, and a supplier. So this could be an example file from a company that is basically dealing with selling or buying products. So what we're going to do is we're going to read the information from this file and we're going to do something with that information. First, we're going to write logic that calculates how many products we have per supplier. So we have 3 supplier companies here, and per supplier, we're going to calculate number of products from that specific company. And as a result, we're going to list the company, so all 3 companies with their respective number of products. Then we're going to write another logic that lists inventory products that have inventory which is less than 10. So basically those ones. The third exercise is going to be to list each company with their respective total inventory value. And finally, in the last exercise, we will calculate the inventory value for each product. So product count times price. And we're going to write that value to an additional column in the spreadsheet. And after that, we're going to save that updated spreadsheet file programmatically using Python. So we're going to see how to update a file and then save it programmatically in Python. If any of this sounds a little bit too complicated for you, then just bear with me. I'm going to explain everything step by step, and it's going to become much clearer when we actually start writing the logic. So the first thing, what I'm going to do is I'm going to take this file that I have in the downloads folder, and I'm actually going to move that into my project. So I'm going to copy that and I'm going to drop it in here so that we have the file right in our project, and so we can basically just read it easily. And okay. And here is our inventory file. So that's taken care of. So obviously what we want to do now is read that file. So basically let our Python program read the contents of that file right here, because we want to write some logic based on the values that are in this inventory file, right? We want to calculate stuff, we want to list some stuff, and so on. So basically we want to work with these values. And in order to do that, we need to read all of these values into our program so that we have them available. So how do we do that? Now there is actually a built-in module in Python that allows you to work with files generally, right? It's not specific for a spreadsheet or for any other file type. It's for different types of files generally. However, there is an external package that allows you to work with spreadsheets specifically. And the obvious advantage is that that external module that allows you to work with spreadsheets, or was created to work with spreadsheets specifically, has much more functions and is much easier to use if you are working with spreadsheets compared to this built-in file module. So that's one of the cases where you may have multiple ways of actually implementing some functionality for your application, and then you have to make this decision of maybe finding a better package or better module which is available externally that will make it easier for you to implement that functionality. So that's what we're going to do for our project. We're going to choose the package that is actually made for working with spreadsheets. We're going to use that one, and it's called OpenPyXL. And if I search for it, this is the package that we're looking for. And if I click inside, basically we have some information about this package. So here we see a description. Let's actually make this bigger. Description, library to read, write Excel files with all of these formats. So this is the library that we're going to be using. In the same way as we did before, we're going to copy that command and execute it from PyCharm's integrated terminal. So from here, I'm going to execute this pip command and install our module. And as you see, successfully installed OpenPyXL. And this is the version of the module that we installed. And in external libraries, site packages, you should be able to see our OpenPyXL package. And now, because the package is available locally, I can do import and open PyXL. Again, I get a suggestion from PyCharm because the module is there. And now we are able to use that package for our application. And one small note here, if you're wondering why there are some packages with basically a dot inside and some without, these are the packages that we install, Python packages. And we know that because there's this init Python file inside, and the ones without the dot, they're just folders with a bunch of files inside, but they're not Python packages, so to say. And inside some of those packages, we see other packages as well with their own init file. So basically hierarchy of multiple packages. And at this point, I'm going to say that the word library basically describes package that includes multiple other packages. So basically, which has a hierarchy of packages. So we have module, which is basically just one Python file that we can use in our project. Then we have package, which is a hierarchy of multiple modules with an init Python file inside. And then we have library, which is basically multiple packages together in a hierarchy, just like we see right here. So note that difference so you don't get confused when you see library, package, and module, especially if used interchangeably. Great, so now we have our module in place. So let's use it now to read our spreadsheet file. And again, you basically have to know the function names to do that. If you don't, you can do dot and get suggestions. And load workbook is actually the function that we need in order to read our spreadsheet file. So I'm gonna choose this function, and obviously we need to tell this function which file it should read. So as a parameter, we're gonna say, please load inventory file. And we even get a suggestion because we have this inventory file here. And there you go. Now, this function will load the workbook and all its contents. And later, we obviously want to do something with that content. So in order to be able to do that, we need to save it first as a variable. And let's actually call it inventory file, like this. And this will give us the file contents. Now let's actually open that file again. And let's see exactly what we need. So we can have multiple such sheets basically per file. So we need to tell the program which one it should use exactly. So for example, if this was called a product list, we would use that name, but we're gonna go with sheet 1. So we're gonna use that name basically. And we're gonna grab that using following syntax. And you remember this syntax probably from using a dictionary. So this will give us this one specific sheet and all the information inside. And we can also save that into a variable. So let's actually call that product list. So now we have read the whole file. Then we have read this specific sheet of that file. And now we have all this information in that variable. So now we can read any of those values and do calculations, etc. using that variable. So let's get to our first task. And the first task is basically to calculate how many products we have per supplier, and then list the names of the suppliers with that respective number of products. So let's go back and do that. So the results, what we want to get is basically products or number of products per supplier, right? That's basically what we want to get as a result. So we're going to create that variable and we're going to set it to an empty dictionary. So by the end, our program should give us something like this. A dictionary where the name of the company is the key and the value is basically product count for that company. And since we have 3 suppliers or 3 companies, we're going to end up with a dictionary with 3 key value pairs per company. So we're starting with an empty dictionary for products per supplier. And now let's see how we can programmatically calculate this. First of all, what we need is we need to go through each of these lines, basically. So we have these rows, so we need to go through each and every row in order, in sequence, and we need to get or check a supplier name for that row. And you remember, whenever we execute a logic on multiple values over and over again, so basically same logic or same function gets executed for multiple different values for a number of times, that's basically a use case for a loop, right? So we're looping through those rows and we're doing the same thing per row, which is getting the name of the supplier. Now, as you also remember, loops have conditions, right? We need to tell the loop how many times it should execute that specific logic. And if we check our file here, how many times we want to execute the logic, the answer is as many times as the number of products. So if we scroll down, we have 74 products. So we need to do that 74 times for each product. So basically as many times as the number of product. And obviously we want this program to work for any spreadsheet file, right? With any number of products. So we need to calculate or we need to read that value also from the file. So basically we need to read how many products are on this list. So let's see how we can do that. First of all, we're using for loop to execute the logic for a specific number of times. And if you remember from for loop syntax, for then we have the specific item. So what is an item in our case? Our item is a row, right? Product row is going to be an item of iteration. So looping basically. So we can call our item products row and then comes in. And now we need that condition. How many times? And again, this should be generic. So we need to calculate or we need to read the number of lines here or number of rows here from the file. And the way we can read that is, remember we have all the information we need in that one specific variable, which is product list. And that variable has the value for number of rows, which is called max row. Now, how do I know that max row attribute is available for product list? I basically just looked it up on the documentation of the module. And as I previously also mentioned, whenever you're using a module, this module will have a documentation. So if you need some functionality, if you need some values, you can basically just search inside the documentation which functions and variables are available to get the functionality or values that you need. And we can actually test it. We can print it out like this. And as you see here, 75. So basically max row will always give us the number of lines or number of rows in that specific sheet. So we know how many times to iterate. Now, whenever we're providing a specific number in a for loop, like 75, for example, in this case, we need to put that number in a range like this. So we can't just say 70 or in this case, max row. Now, why do we need a range here and why is number just not enough? Because the for loop is for iterating over a list. And the range will create a list of numbers to iterate through. In our case, a range of 75 will create a list of numbers or sequence of numbers from 0 to 74. And with that, we're going to have a valid for loop where for each item, in this list of numbers, some logic will be executed. So that's why we need a range here. And now there's one more thing that we need to fix. If we go back to our spreadsheet, you see that the first row, so this is going to be the first row basically, does not actually include the product information. It just includes the titles for each column, right? So we actually do not want to read this line. We want to skip it. And we want to start from the second row. So instead of starting for loop from the first row, we want to start it from the second row. And in order to tell Python to start at row 2, in the range function, we're going to pass first parameter 2. So basically this will give us a new range of numbers starting from 2 instead of starting from 0. And since we're using those numbers in the range as an index for the rows, the first number is going to be 2. So we're going to start iterating from the second row. So this will be the start point and this will be the end point. So basically from here to the end. Now there are two things specific to a range that you should be aware of. First of all, when we do not provide the start index, basically the start number in the range, by default it's actually 0. So it's not 1, but it's 0. And obviously we don't have a line 0 here. So if we executed it with the default 1, we would get an error. So that's one thing to consider, that range actually by default starts at 0 and not 1. But for us it doesn't matter because we're skipping the first one anyways and we're starting from line 2 because our spreadsheet doesn't have line 0, obviously. Another specific of the range is that the second value here, basically the last number of execution in the loop, in our case this is going to be 75 because we have 75 lines and we printed that out here. That number is actually exclusive. It's not inclusive. That means that the range will execute from line 2 to 75 exclusive. So basically till here. This line will not be included in the loop. Again, that's a specification of the range which we need to fix, and basically want to tell, you know what, we want that iteration including the last number as well, including that max row. And a simple fix for that is going to be to do +1 here. So basically whatever the max row is, we want to include that one as well. So we want to add 1 to it. So now we have a range starting from 2 and ending in 76 exclusive. So obviously the 76th line will not be read. And this will now give us a range that we need. And now that we have condition for the loop and we have said how many times they should execute, let's actually execute the logic itself. So what is the first information we need from that product row? For each row, we basically need the supplier name so that we can increment or start counting how many products this supplier has. So we need this 1, 2, 3, fourth column and the value in that fourth column for each and every row, right? Let's go back to editor. How do we get a value in the cell? You have to imagine when we iterate, we have 1 row per iteration. So right here, we actually have this product row, which is just 1 row, and we have 4 columns here, and we want value in this specific cell. And we can get it using, first of all, product list, because again, we have all the information here. So on this list, we need a cell, right? We need a value of a cell. So that's the name of the function. And this cell basically takes 2 parameters. Again, product list contains the whole sheet here, so the whole list with all the rows and columns. And we can get a specific cell value, so whatever we are, doesn't really matter, from that variable by providing 2 values, the row number and the column number. That's it. So row 9, column 1 basically will be this specific value. Row 5, column 4 will be this specific value. So for each iteration, we're gonna do exactly that. So for our case, the supplier is always column 4, and the row is dynamic because we are iterating, and therefore we're gonna use whatever row we are at the current iteration. So that's the first parameter and column 4, as I said. And this will give us the supplier name for each and every row. So we can grab that value like this, and this is going to be supplier name. So we can save it in a variable. As a next step, we're going to start building how many products each supplier has. We're going to start building a dictionary with the name of the supplier and then how many products they have. So we're going to be building this dictionary here. So this is a reminder now for what I said previously, that you don't need knowledge of math in programming, rather you need logical thinking, right? So you're going to get tasks like this where you have to basically logically decide how you are going to do a certain task and think all this through, right? So programming is more about logic rather than pure calculation or math, which is actually more interesting and cooler. And that's exactly what we're going to need in this example. We're going to need some logical thinking to basically build this application. So bear with me on this one. The first thing we need to check here, so think about this iteration on the first time and the second time. The first time the list or the dictionary is actually empty, so we want to add the first supplier to the list right away, right? So we're going to grab that, and the syntax for adding a new entry in a dictionary is like this, where we have a key and a value here. So basically what we want to end up with is supplier name, like a company, and number of products for that supplier. That's the dictionary that we want to end up with. Then it's going to be BBB, company, and so on. So the very first supplier goes directly into the list, and we're going to need the name of that supplier. We don't know what it's going to be. So name as a key, and value is going to be 1 at the beginning, right? This is the very first iteration. So after the first iteration, we're going to have the first company name, supplier name, and count 1 for that. On the second loop, second iteration, basically, if the next line is a different supplier, like here, for example, then a new entry will be added because we have a new key now with count 1, right? So now we're going to have company A with 1 product, company B with 1 product. Now what happens when on the next iteration we get company A again, right? What we want to happen is company A, the product count to increase to 2, right? Because now we found another product that is supplied by the same company. However, with this line, we're actually overriding and setting it back to 1. So how do we make sure the number of products gets incremented instead of always setting it to 1? What we're going to do is before we execute this line, we're going to check, is it a new supplier or an existing one? Because that makes a difference. So how do we know if it's a new one or an existing one? We can look that name up in the dictionary. If we have already added that name in the dictionary, then it's going to be there. And we can do that very easily, again, with the syntax, if supplier name in the dictionary. It's actually very readable syntax that says, is the supplier already added to the list or is it a new one? So if this is true, again, remember if conditional. So if this is true statement, if the supplier name is already there, then it is an existing one. So we need to increment the product number instead of setting it to 1. So instead of assigning a new value, we want to grab that value, the existing one, and basically add 1 to it, right? just increment by 1. So getting a value from a dictionary, you probably remember the syntax already, using the key, and we can save it into a variable. Let's call it current number of products, like this. Remember, we're using a key in order to get the value, and the key is the supplier name, value is the product count. So this will give us the current number of products. On the first iteration, this will be 1, or after the first iteration, we're going to have 1 product for that specific supplier. And if we already have that supplier in the dictionary, we want to increment the number of products for that specific supplier by 1, because we just found another product from that supplier. So we want this value to now be plus 1, right? So current number of products plus 1. So that's the new value that we want for this current supplier. And how do we assign it back to the dictionary? Again, we grab that and assign it. So as you see, taking the value from the dictionary has the same syntax as setting that value in the dictionary. In fact, we could actually use a shortcut here. So instead of current num products, we could just take that value and add plus to it, and then set it back as a new value. And this will basically just give us a one-liner for the logic. Depends on the taste whether this looks nice or not, or whether it's better to have a new variable and increment the value like this. Let's actually leave it like this. So this logic will take care of adding a product count every time we find another product for the same supplier. However, now we have to decide what happens when it's a new supplier. So if this condition is false, if the supplier name is not on the list, and this is going to be the case on the very first iteration as well, because the dictionary is basically empty, so there are no supplier names. And for that case, else, we're going to do what we had before, which is just setting that number to 1, right? This is going to be the first value. So this will do 2 things, basically. It will create a new entry in this dictionary for this new supplier, and it will set the product count number to 1 for that new supplier. And that's it. That's actually our logic. And let's actually try this out and print it out. So right here, I'm going to print adding a new supplier. And this is going to happen 3 times because we have 3 suppliers. So we can safely print it because it's just going to happen 3 times. There is one more thing we need to fix here, and that is getting the value from the cell. So if we actually execute this now, let's comment this out and actually print out what the supplier name here is. Let's actually get rid of this line. We don't need this. And run the program. You see here we have cell information. So it's not actually the value, the name of the supplier, but it's just the object cell. And the reason for that is because we're accessing a cell, but we're not actually extracting or getting the value out of it. And we can do that using this value attribute on that complete object. Again, something that you can look up in the documentation of this OpenPyXL module. So now let's run it again. And now we have the actual values of that cell. And this will take care of that small problem. And now we are ready to execute our program. And after the for loop, actually, let's print out the dictionary because we want to see the results of the dictionary that we are building here. And I'm going to execute it now. And there you go. First of all, we have 3 times adding a new supplier because we have 3 suppliers. And this is the resulting dictionary. And it looks actually very good. First, we have company A because this was the first on the list. And we have number of products that were counted for that company. Then we have the second one with number of products and the third one. So it looks like our program did exactly what we wanted. So that takes care of the first exercise. Now I want to note here one small thing, which is an alternative syntax for getting values from a dictionary, which is actually a more recommended way of doing it, which is instead of having these brackets here, to have a get method, right? To use a get function with the key name. So now you see the difference between those two. So this is setting the value of that key. Again, remember key is this one here and this is the value. So we are accessing the value of the dictionary using that key. And get function is actually another way of grabbing this value out of a dictionary using the key name. Again, if I execute this, I should see the same result. After the first exercise, basically we see from which company or from which supplier we have the most product or the highest number of products. Now in the second exercise, we're going to calculate the total inventory value per supplier, meaning in our list for each product we have number of units for the product and the price. So basically for each supplier, we want to calculate how much is the total value of inventory of their products, of all their products. And again, as a result, we want to create a dictionary that basically tells us that value per company. Let's go ahead and do that. So this was calculation for number of products per supplier. And here we're going to give us some space and do calculation total value per supplier, or total value of inventory per supplier. That's what we want to calculate. So just like we did before, we're going to create a new dictionary now, and we're going to call it appropriately total value per supplier, and start with an empty dictionary. Again, for starting in an easy way, let's consider the very first iteration for the first supplier. How are we going to calculate for the first supplier for the first product? So I'm going to take this new dictionary, and with our familiar syntax, I'm going to do supplier name. So that's going to be our key. And the value of the very first iteration for the first product is going to be inventory times price. So for the first product, we're going to calculate how much or how many of the product items we have and number of price, right? That will give us value of the total inventory for that one specific product. And that means we need those two values. Right now, we're just getting the value of the supplier. So we need inventory. I'm actually going to copy this. So we need cell for product row and column. Inventory is on column 2 and value. So whatever the product row is going to be, so for each product, basically for each row, we need always the second column. So all these values here. And then we need price, which going to be product list cell. And we're looking for the third column for every row. Number 3 and value. So now we have inventory and price per product. And the way to calculate value is basically inventory. That's the number of product items times price. Very easy. That will give us the first value for the first supplier. Now, again, the same way, if we are getting a new supplier, So basically in the next iteration, if it's a new supplier, then this line will get executed and everything is fine. However, if it's an existing supplier that we already have in the dictionary, then we have to add to that previous value, right? Instead of setting a new one. So we're gonna do very similar logic as we did here. So we have the supplier name. We're checking, is it a new supplier or an old one, an existing one? This time in our new dictionary. And if it is, we're gonna grab that old or existing value, again using this get syntax here. Existing value now is 100. We want to add to that 100, right? So we're gonna grab that value. This is gonna be current total value. And then we're gonna add to that current total value the inventory value for the current product and assign it back to our dictionary. Now our variable names are a little bit long, so the code kind of looks a bit cluttered, but it's easy to read and descriptive. So you can also go for shorter variable names to have a cleaner code. Again, matter of taste. I usually name the variables something descriptive, something that basically really differentiates or says what the value is about. And that basically takes care of existing suppliers or the suppliers that we already have in the dictionary. Else we do this. And this is complaining about too many blank lines, so let's fix that. And that's basically our logic. Again, to go through it once, for new suppliers, again, this is going to happen 3 times because we have 3 suppliers. We're basically setting the total inventory price or inventory value for that specific product, because remember, we are iterating through products. And then every time a new product iteration happens for the same supplier, we basically just add an inventory price or total value for that specific product for what we already have in the dictionary for that specific supplier. So now let's again print out our dictionary. Let's actually print both values. So the first dictionary is this one right here, supplier and number of products. The second one is going to be supplier and total value of all the products they have in the inventory with us. Execute, and there you go. We have both dictionaries printed here. And here you see for each company, we have the value in price, basically, right here. The value for the total inventory of all the products they have on this list. And we see that value per supplier. And the values are decimal numbers with cent precision, so 95 cents, 47 cents, because the prices are obviously like this as well. And if you're wondering, this comma here is actually a German format for number precision. So this is going to be actually equivalent to English dot. And we don't have to worry about this actually because Python reads it and interprets it correctly. So no problem with different language formats. So that takes care of our second calculation. Now the third logic we're going to write is basically printing out all the products that have inventory less than 10, like these ones here, for example. So the logic for that is actually going to be pretty easy. What we need as a result is, again, a dictionary. Let's call it products, which have inventory under 10, like this. And the value in the dictionary should be the product number, which we have in the first column, and the inventory count. So let's get rid of these print statements and let's do calculation, or we can do logic. products with inventory less than 10. So basically, as I said, for each product which has inventory under 10, we want to print out, or we want to save in a dictionary, the product number and the inventory count. So we have the inventory count already, the value from the cell, but we don't have the product number. We're not accessing it. So let's actually do that. Product number. And we already know how this works. This is going to be the first column, right? This one here. And this gives us the product number. And now in our dictionary, products under 10, we want to add value like this, product number, and it's going to be set to value of the inventory, like this. However, we don't want it for every product, we want it only for products with inventory less than 10, and that's going to be an easy if conditional here. If inventory, again, remember this logic, all this logic happens for each product row, right? So all these get executed for each of these rows. So basically we have inventory number on each iteration for each specific product. And that's why we can just say if inventory is less than 10. So if the value on that specific row is less than 10, we want to add that product, the current product that we are iterating on the list, and set the value of inventory as well. Again, we have some complaining here because of the lines, and this will be the logic basically. And a use case for this type of calculation would be if we find products that have inventory which are less than 10, means we need to reorder them, right? Because they're gonna get out of stock soon. And now at the end, let's print the list of all the products that have inventory less than 10. So I'm going to execute it. And here we have the product number and inventory count. So we have 3 products basically which have inventory less than 10. And let's actually check that. Product number 25 right here, which has inventory of 7, and product number 30, inventory of 6, and the third one as well. Now you're probably wondering why we have this .0 here, because by default those values are interpreted as float numbers and not integers. If we wanted to, we can actually fix that using the integer function in both cases, like this. Let's execute it again, and we have the integers and not floats. And finally, as a last exercise, what we're going to do is we're going to actually add some value inside that spreadsheet. Till now, we have been reading the values and doing some calculations and just printing the result on the terminal. As a last exercise, we're actually going to create a new column here for every row, and we're going to calculate basically the total price of inventory, right? The number of units times the price. And we're going to basically set the value for each product, inventory multiplied by price. So how do we add a column, or how do we make changes to a file? It's actually pretty easy. The same way as we were grabbing the value from this file and basically reading the values, we can add values to it and add columns and rows, etc. So to add a 5th column, we're going to do product list, cell, product row. This is going to be the number of the row, and a column number. So the same way we accessed the cells for all other values, we can basically access the cell on column 5, which has an empty value, right? So we're not actually creating a new column, we're just grabbing a value of a column 5, which happens to be empty, and we're overriding that value. And we could do the same actually for any other columns here, right? We can override all these values if we wanted to. So that's basically what we're doing. So we're grabbing that cell and we can now save it into a variable. Let's actually call it inventory price. So now that cell is saved into that variable so we can reference it. And note here that I didn't add dot value at the end, because if we want to update the cell, we need the whole cell object, right? So that we can actually set a value on that. So how do we set a value for that specific cell? So again, note that this is iteration. So for each product row, the value will be set. So how do we set the cell value? I'm just going to grab this variable here, inventory price, which is representing the cell in column 5 for each iteration. And right here at the end, because this is our last exercise, let's write, this is a logic, or basically add value for total inventory price. And the way we set the value in the cell is dot value equals, and the calculation for that is actually very easy. We already did it here. Inventory times the price for that specific product, and that's it. So we're using that dot value here in order to set the value instead of grabbing the value. And that will actually update and add this calculation or result of the calculation on each line on this column. But note that this will only change the value in a temporary file, but it's not going to save anything, right? So what we want to do at the end, if we want this change to persist, to actually be saved, we want to explicitly save the file. So for example, if I manually did something here, added some value, I would need to save it here as well, right? So that's exactly what we need to do here, but programmatically using Python. So how do we save a file using Python? Again, this package or this module that we use here also gives us a function that we can use to save the file. And since we're doing an operation on a file and not a sheet here, we're going to grab that variable in file, and here at the end, we're going to call a save function on it. And this will save the file changes. However, we're not overwriting the same file, the existing inventory file, we're creating a new one. And because of that, we need to provide a name of the new file that is going to be created with this save function. And we're going to call that file, let's say inventory with total value and extension, the same extension as we have here. So this line will now save the changes and create a new file from the original one, which has these values generated basically. So now that we are done with the fourth exercise, let's actually print out everything. That we've done so far. I'm going to take all those values. So this is going to be execution of all our logic, printing these 3 dictionaries here, and then updating the spreadsheet file and saving it into a new file. So with this, let's actually execute our program and see what happened. First of all, we have all those 3 dictionaries listed here or printed here with the values. And if we pull this aside, here you see a new file got generated with the name inventory with total value. And if we open this file, we should see that for each row, a new column was generated and filled with values, which is calculated for each product's inventory and price. So that's basically our project. That's how you work with files in Python, specifically with spreadsheet files. And as I said at the beginning, this could be actually a very useful automation logic when you're working at a company where there are lots of Excel files or spreadsheet files that employees have to work with and manually update stuff inside. In this part, we're going to learn the concept of objects and classes in Python and generally object-oriented programming. Let's consider an example of an application with lots of users. For example, LinkedIn, right? We have users and each user will have some information. For example, email address, name of the user, password, maybe a current job title, work experience, a set of skills, and so on, right? So each user will have all of this information, but obviously the actual values, the actual information will be different for each user. In addition to that, users are able to do something with their own information, right? So for example, a user can change their password, change their current job title, add a new skill, and again, basically do stuff with their own personal information. And our program will be able to handle this user information plus user changing their information, right? So this will be user data, and in order to do something, so to perform some action, we would have functions for that, right? So all of these will actually be functions. However, as I mentioned, every user will have their own data, and whenever a new user basically registers for an application, all this data should be gathered for that new user and saved in the application. So basically that means that in our program, we need some way to define kind of a blueprint for a user, for all the data, user information, and user behavior, right? Things that the user can do in the application. Because if we have 1,000 users in our application, obviously we can't write the same logic and same variables 1,000 times, right? We want to have a blueprint once, and then we can use the blueprint for all those 1,000 users. And that blueprint for a user is called a class. And the specific implementation of that blueprint is called an object. So think of this like a blueprint of a building, right? You can have a blueprint once, which is like a general description of a building with doors and windows and everything that every single building has. And then the specific implementation of that blueprint will be the actual built ready buildings, right? So that's the same concept. We're going to create a class blueprint for a user, and the user class blueprint will define what information a user has and what actions user can perform in the application. An object then will contain the actual information, like this information right here for each specific user. So let's clean all this up, and let's now actually create class user. So let's create a new file in our project, and let's actually call it user.py. So this is going to be our user class. And inside that, I'm going to paste in this piece of code that basically will represent data for the user and some behavior. These pieces of data are also called attributes for that class. So now let's turn all of these into a class. So first of all, we create a class using class special word, and you also see the syntax highlighting, and we're going to call that user. And you know the syntax already for functions, etc. with indentation. So this is going to be where our class definition goes. Now note here the capital letter for U, for user, and lowercase user in the Python file name. So a standard convention is that we call classes with a capital letter, and the file names are written in lowercase letters. And now all of these should actually go inside that indentation, right? Like this. Now we said that class is a blueprint for specific objects, and blueprint cannot actually have specific values, right? So all of this needs to be removed. So in the blueprint, we don't have any specific values, we just have the attributes. So basically we say this user will have an email, name, password, and current job title. The actual values of those attributes will be then set when we create an object from the blueprint. However, we need a function that will actually take those specific values and assign them to an object which is created from the blueprint. And we're gonna create that function right here in the class. And that function actually is called init with underscore or 2 underscores at the beginning and at the end. A couple of notes here. First of all, you see the syntax highlighting just changed to this different color. Second note is that these functions that start with underscore in Python are special functions. So Python basically gives them some special meaning. So it knows exactly what this init function is. And we also have to call it init. We can't just call it whatever we want. And final note is that this init function in Python is something called a constructor. Again, we have a blueprint and we're constructing objects from that blueprint. And this init function, the constructor function, will help us construct objects from that user class. And now for a function syntax, you know that we use these brackets, right? And when I start writing the bracket, you see that self got automatically created as the parameter here. And the reason is, as I mentioned, Python knows what the init function is and that it's a constructor. So it knows that it needs this self as a parameter. Again, self is also a special word in Python. It has a special meaning and it actually refers to this class here, right? This entire class. If I hover over it, you see self points to the user class. And it will basically just help us access and reference all the attributes and functions within that class. So it's for special usage within that user class. And we're going to see examples of how to use that in a second. Now you can think of those attributes as variables within the class because they belong to the class, right? They describe basically what attributes or what characteristics this class has. And in order to define that these variables belong to the class, we need to use self here. So, and you see again, syntax highlighting changed and the red line disappeared. So basically we're defining that email, name, password, and current job title belong to this class using this self keyword. And now the last thing remaining in this constructor, again, remember constructor is to construct new objects. So whenever a new object is created, the specific values will be assigned to all of these 4 variables, right? And those values, those specific values will be passed into the constructor as parameters. So email, name, password, and current job title. Those 4 values must be provided to the constructor whenever we're creating a new object. Note that these names here could be different from this. These are not the same, these are just parameters. And using these parameter values, we're gonna basically set the variables or attributes of the class. Like this. And the warning is gone as well. Again, as I mentioned, this could be something else. We could call it user email. So it doesn't actually have to be the same, just for convenience. So this function will construct an object with parameters that we provide when we actually create it. And we're going to see how to create an object later. This is just a definition. As remember, when you define a function, nothing actually happens until you call or you use that function. So right here, we're just defining that function so that we can use it later. So constructor logic is done. Now we have these 2 functions that any user in our application can do, right? Any user can change their password or change their job title. And logically, when change password happens, by user. Basically, user provides a new password in order to override the old one. So the flow will be following. The object will be created for the specific user. So the initial data for that object will be provided. So we'll have the user, email, name, password, and current job title. And later at some point, user may decide to change their password and their current job title. And that means the initial data will be changed. And that means that we're actually changing the attributes self.password with a new password, right? So logic will be like this. Now we have red lines here. Why? Because we need this self as a parameter. First of all, we also have that as a note right here. So just like here, we need to actually pass that self as a parameter. That's just how it is, because we need to access attributes of that class in that function. And new password will be a new password variable will be the new password basically that user wants to set. So this will change the initial password with the new one. And the same way in change job title, we have self as a first parameter. We always need it in all the functions because otherwise we cannot access the attributes in the class. And new job title. So now let's review this class that we created. First of all, we have this class keyword here with a capital letter for user. You already know the syntax with colon and then indentation. So this, all of this inside this indentation is class body. So part of the class logic. First, we have this init constructor that sets the initial values of that class attributes whenever we create specific object for that class, right? So this happens only when we construct a new object, and then on that constructed object, we can change password, we can change job title. And note that right now we have nothing basically hard-coded. We have no specific values here, right? Everything is just parameterized. And also, this is just a definition for class and its functions. Nothing will actually happen when we execute this because we're not creating any user objects. So if I right click here and execute this, run user, you see that nothing happened because the class definition was created, but we're not doing anything with that class definition. We're not creating new users. So now let's actually go ahead and do that. In the same file, in user.py, I'm going to actually use that class blueprint to construct a new user object. And creating an object from a class is actually very simple. We just write name of the class and parentheses. And this is actually the same syntax as calling the function with parameters. And the parameters that we need to give that class are these 4 values here. And note that calling this user class function basically in the background will call init function, right? So the constructor will be called whenever we write this syntax with class name and parentheses. And this init constructor, as you see, expects 4 parameters. So we have to provide all those parameters right here in the parentheses. So let's actually provide them. Let's do user email like this, my username and password, and a current job title. Again, very similar to calling a function, and this will actually construct a new object from that user class, which has these 4 attributes with values that we just provided here, and has these 2 functions that we can use to either change the password or change job title. One note here is that functions that belong to a class are actually called methods. So there's a special name for functions which are part of a class. So we can refer to them as methods. So user object basically gives us two methods that we can use. Now again, if we execute this program now, we will not see anything, even though user will be created, because we're not printing anything to the console. We're not doing anything. So let's do that. Run user. Nothing happens because we need to print a message or some kind of information. So what I'm going to do now is inside that class, I'm going to create a function or a method, as we learn now, that basically prints back some user information, right? Prints me the name, email, and current job title, because we don't want to display password. So let's give us some space here, and let's create a function called getUserInfo, so that we can see something. And again, as soon as I typed in these first parentheses, self got generated, because we need self in every function within the class. And in the function body, we're gonna print user information. So let's say user and name of the user, which we can access using self. Remember, all the attributes that the object has can be accessed with this special word here. So self.name. So user, whatever the user's name is, currently works as a, and now we need the job description or job title, and you can contact them at, and now we can use the email. So this message will be printed for the user, again, because this will be used for any user of our application. The message, these parts will be the same, but each user will have their own different name, different job title, and different email address. So all of these are parameterized and written as variables because we don't know these values up front. So now we can actually use this function or method to print out information of a specific user. So how do we use, or how do we call that function of the user? We first save it into a variable, AppUser1, or Nana, doesn't really matter. Let's call it AppUser1, so it's generic. So how do we use that function to print out the information about the user? If I do AppUser1 and dot, you see that I have the attributes here, the 4 attributes that our user object has, or user class, and we have these 3 methods of the class: getUserInfo, change job title, and change password. So using getInfo, we can call this function. And if I execute this, right here you see user Nana Janashia currently works as a DevOps engineer. You can contact them at this email. And now let's say we want to change the job title of that user. We do that in the same way, AppUser1 dot change job title, and we're gonna provide the job title parameter. Note that even though you see 2 parameters here on that function, this first parameter is passed in automatically, so we don't have to basically pass that self, right? It's already done automatically. We just have to worry about these parameters. So new job title is, let's say, DevOps trainer. And now we can call that UserInfo method again and execute. And you see, first message printed here before we change the job title. Now it's DevOps trainer. So that's how we can create a new object from a class, and we can use methods of that object by first saving that object into a variable and then calling that function on that variable. And obviously now this is just one user, but if we had another one, user2, let's actually clean this up. We can create a new user with different values like this. They have their own email, own name, own password, and own job title. And again, we can create that user and basically just use the methods defined in the class. And in two different cases, or for two different users, obviously the user info will be different. So let's execute this. And right here you see the user information for both users. And obviously, if you have an application like LinkedIn, you don't have 2 users or 1,000 users, you probably have millions of users, and having a user definition once and reusing it every time a new user gets created, or basically existing users do something in an application, is only possible when using classes and objects instead of just having all this logic non-structured throughout the code. And again, in this type of applications, you would not have 4 attributes and 3 methods. You will have probably hundreds of attributes and hundreds of such methods. Now, as you see here, we have created this user.py file for user class, but we're also creating these objects in the same file, which actually doesn't make sense because the file should be only for defining the class, right? So all of this logic actually needs to move out from here, and this should be just only for class definition. So in the application, again, using an example of LinkedIn, we would have class user, and then we would have a class post, right? Whenever someone posts something, each post will have their own attributes, like the actual message or text in that post, the author who wrote the post, how many likes it has, etc., as well as specific functions, right? For example, changing the post, commenting on the post, etc. So you will have separate file for each such class, right, in the application. And then you would have one file somewhere else. This could be a main.py, where you would actually use all those different classes and create objects from those classes. And that means that logic that we wrote here, constructing a user object and then calling some functions on that, will actually happen in another file. In our case, let's use main.py. And now let's see how we're going to do that. I'm going to paste in the code that I copied from there. And as soon as I paste in, you see those red lines. So basically, main.py says that it cannot find a reference to user. So this file doesn't know anything about the user class. So how do we fix that? Or how do we make this user class available in another file? And if you remember, when we needed to use modules, or basically functions, variables, whatever, from other files in Python, we used import to basically import those functions and make them available here, or import the whole module to make its functions and variables available here. And the same way, we can import classes from another file. Import user. And note here that I'm using the name of the file, user, lowercase, and not the class name with capital user, right? So we are importing that file. So now we can use anything that is defined in that file. And one of them is a class called user. And the way we can access that class now is using the name of module and not the class user itself. And this is basically exactly the same concept as we saw before, because we're importing a module called user. Remember, every Python file that has functions or variables or classes inside is a module. So we're importing a module, and once we have that module imported, now we can use and access functions, variables, or classes of that module. And we can do that by copying the name of the module, dot, and there you go. And the same way here. So exactly the same concept, whether this is a function or a class, doesn't matter, we use it the same way. Remember when we used the datetime module with the syntax datetime.datetime, And that was an example of using a class from a module. Now, user.user may look a little bit weird, so we can use our familiar import statement, where instead of importing the whole module, we can pick and choose and import specific definitions or specific elements of that module. In our case, we just have one element, which is the class. So we're going to say from user module import user class. And now we don't need the module name anymore because we imported the class itself. And now if we execute main.py, let's do it again. Here we have the same result for 2 of our users. And again, as I said, in applications, you will have multiple classes that are connected to each other. So for example, if we have a post here, post blueprint, basically, whenever a new post gets created with some specific values like the actual message and creation, date, time, etc., it will also have an author, and that author will actually be one of those user objects, right? So you will have some functions here that actually reference the post. And we can also see that in action. Let's actually create a post class. And let's give it just 2 attributes to keep it simple. So we need a constructor here, init, and we're gonna pass in message and author, right? This is gonna be the user who wrote it. And you know the drill already. And let's create another function which displays a post with its respective author. So let's do get post info. Again, we have self here, and let's print post written by and the author name. So this is going to be our simple post class, and user is able to create new posts. So we have the blueprint for a post, and the same way we can create that post inside the main.py. So first let's import the post class. And then here we're going to create a new post. In PyCharm, you get this nice display of parameters that function or class basically expects. So we have message and author. Let's do some message or post. And as a second parameter, we have the author, and we can use the name of a user. So let's do AppUser2.name, and this will create an object also called instance in programming, a special instance of that post class, and then we can print the information of that post. First assign it to a variable. Let's say it's a new post, and on a new post we're gonna call get post info. Let's actually run this application now and see the result. And here we have our post message that gets printed by this get post info method in the post class. And at the beginning I mentioned object-oriented programming, which basically means that when you're writing your code with objects and classes like this to create blueprints and then use those blueprints for specific instances, that's called object-oriented programming. And also an interesting note here is that in Python, almost everything is actually an object. For example, the data types like string, integer, list, set, etc., when we printed them out, we saw class of string or class of list. So these data types are also classes in Python. And this int or str for string functions we called were actually the constructor we called to create a string or integer object. And the constructor of int, for example, took a string representation of a number and in its init function and constructed an integer out of it. Now for us, in terms of using these data types and variables, etc., it doesn't actually matter, but it's just an interesting thing to know about how this whole thing works in Python. In this part, we're going to learn how to use Python to talk to external applications. In our case, we're going to use GitLab as an application. And just a note here that communication between two applications, in our case, our Python application and a GitLab application, usually happens using a common protocol like HTTP. So basically, our Python application will send an HTTP request to GitLab application, and from the GitLab application, it will get an HTTP response for that request. So just note that HTTP is just a protocol that these two applications can communicate with over the internet. I have a couple of projects on GitLab, so we're going to write a very simple Python application that basically goes to GitLab and asks for the list of projects for my user and then just prints it here in our run window. And the concept of one application talking to another is basically done using something called API requests. So the remote application, in this case GitLab, has an API. So these are functions basically that GitLab makes available for other applications to call. And we're going to call those functions from our Python application in order to get the list of projects for my user. And that communication, or Python basically asking for this information, is going to be an API request or API call. And what we get in response from this GitLab API is going to be API response. So let's go ahead and do that. In Python, in order to make those external requests to remote applications, we're going to need a module called requests. This is a generic module that you can use for any external application. And as I mentioned at the beginning, the communication happens using HTTP protocol between two applications. And as you see here, also in the module description, it says an HTTP library, which allows you to send HTTP requests and then receive HTTP responses from another application. And that's exactly what we're going to be doing. And this request module is not part of Python, so we're going to install it using pip. Again, remember that we're using pip that actually comes packaged with the PyCharm. So in the terminal window of my IDE of PyCharm, I'm going to execute pip install requests. Successfully installed request. This is the version of that module. And if I expand these external libraries, side packages, I'm going to see the requests package in the list. Great, so once we have the module available locally, we can import that module in our file. And this requests module now has, or package actually, has functions, variables, and objects that we can use to talk to these remote applications like GitLab. As I said, GitLab is just one example. You can talk to any remote application that has an API. And we can not only do requests for getting the existing information, but we can also make requests to change something in that remote application. So for example, I could write a Python application that will actually create a new project on my GitLab account. But to keep the demo simple, we're just going to be fetching information from GitLab. So how do we make requests to an API of an application? With this requests module, we get a function called get, and get takes one main parameter, which is URL. So basically we need to tell Python where to find that remote application, or again in our case, where to find GitLab to talk to it. So we need the URL of GitLab. And where do you find this URL information of a remote application? You can basically Google that. Every application has their own documentation where you can see the URLs. So for example, for GitLab, I actually Googled it. So if I do GitLab API documentation like this, let's make it bigger. So you have basically description for the API and what type of information you can get from GitLab, and also what kind of things you can create in GitLab. And you see an example API here that basically just lists all the projects. However, we want to list projects of one specific user. In this case, I want to list my own projects. And in this documentation, I found this list user project section where I have an example of how to use projects for a specific user. So we have /users and the user ID. So that's going to be my GitLab user ID and projects. So basically, the URL will now look like this. First, we're going to have this base URL. So that's basically https://gitlab.com API v4. And all the things that we want to do is going to be at this base API. And after that, we can basically, depending on what exactly we want to do, we can choose one specific action. And again, going back, this is the action we want to execute on this base URL. So from GitLab, we want projects that belong to a user. And right here, I'm gonna add my own GitLab user ID. So if you have a GitLab account, you should add your own user ID here. And that's gonna be an API URL for user projects. And this will actually give us some kind of response. So requests.get will make that request to GitLab, and it will return some kind of response. And we can save that response into a variable. So let's call this variable response, because that's what it is. And on the next line, let's actually print and see what's in that response. Let's run our application. And right here you see we have an object response with a code here. 200 is a code for a successful request, but we're not seeing the actual contents, right? We want to see the projects with their details. And in order to get that, we're gonna do dot and text. And let's actually execute this now. And now you see these square brackets, which means it is a list, because we have a list of projects and this whole bunch of information about projects there. And you also see curly braces. So this is a list of dictionaries, and each dictionary holds information of one specific project. Now, if I actually print the type of that response text, like this, you see that it is a string. So even though we see the format is actually a list of dictionaries, we're getting a string because we're accessing text attribute. Now, there is actually another attribute which will give us the same thing, but as an actual list of dictionaries instead of string. And this will be actually a better way to get that information, because then we can work on it. So we can loop through it and get the individual elements and access the values. So what I'm gonna do now, instead of .text, I'm gonna use JSON. JSON is a standard format that all programming languages understand. And usually when two applications communicate with each other, which are written in different languages and with different technologies, with JSON, they have a common format for communication. And this requests module basically gives us this JSON function to read the JSON format that GitLab sent us. So JSON function will read the JSON response from GitLab and turn it into one of the Python data types. So I'm going to execute this now, and now you see that response.json actually gave us list data type instead of string. So again, for demonstration, since this is a list, I'm going to access the first element of that list and print that out. And right here you see that is actually the first element, just the first one from the list. And that element is a dictionary, as you see. So all of this just to give you an idea of what we're getting back from that GitLab API and what we can do with that response, or how we can actually work with that response. So I'm gonna clean all this up, and we saw that response.json gives us exactly what we want. And that is list of my project. So let's call this variable my projects. And now what I want to do with this is I want to print out in our window for each project, project name and project URL. So basically the repository URL for that project. So I don't want to have any other values like ID or description or whatever other stuff I have in this dictionary. I just want name and project URL for every single project. And I want that information printed out in this window. So how do we do that? We have a list. So we're gonna loop through that list to access each element inside that list. So you remember we have for loop to loop through or iterate through a list and give us access to each element one at a time. So here I'm gonna write for loop. And if you remember the syntax of for loop, we have for and then a variable which will represent a single element in that list. And in this case, it's gonna be a project, a single project. And then we have in list. So for project, in my projects, do something. So for every project element in this my projects list, we want to print out the name and the URL. So right here, I will do print. And let's do our formatted string here. And let's start writing our message. Let's do project name. And the project name will be this one right here. Now, how do we actually access the name of the project in each project element? As you see here, these project elements are actually dictionaries. And how do we access a value in a dictionary? Using the name of the dictionary, in this case, our variable project. So this whole thing is going to be saved into a variable called project. And then on the variable, on the dictionary, we're gonna pass in the name of the key, which is name. Now, I've been using double quotes throughout our project, and for a syntax for dictionaries as well, like this, right? However, here we have a small problem, which is we have double quotes inside the double quotes. But as you remember, for string representation, we can actually use single quotes as well as double quotes. And this is one of the really important use cases for why we can actually use both single and double quotes for a string. And that is if we have a string inside another string, like right here, we can actually use that interchangeably so that we don't have this problem here. So now, as you see, back to normal, everything works because now Python knows, okay, this is another string which we're using inside this string. So we can use these interchangeably as we want. So this could be single quotes and this could be double quotes, wouldn't really matter. But that's a really good use case why we need both types of quotes. So we have the project name. Now we need a project URL. And let's see where the project URL is in our dictionary. This is one element, one dictionary, right? So I'm gonna scroll it to the left. And we have web URL. This is what we could use. Or we could also use HTTP URL to repo. Let's go with the web URL. So again, this is a key inside a dictionary. So we can access the value. So this is actually the value we need. And we can access that using the dictionary name, projects, and the key name, which is web URL. And this is actually project. not projects. And this code will now print name and URL for each project. So let's actually execute our program. And as you see, we have project name and project URL for each project. We can make the output a little bit cleaner. Let's do a new line here and a new line here. So we can separate the projects from each other and run again. And there you go. This looks a little bit cleaner. For each project, we have a name and a URL. So if I click inside, I'll go directly to this project. So that's basically a very simple example of how to use requests module to talk to external applications or external URLs, and then do something with the response that we get from that external application. By first converting that into an actual data type that we're getting using JSON function. So in our case, it was a list, and that's why JSON function actually converted it into a list. If the response was a dictionary instead of a list, then JSON would convert it into a dictionary. And then we can do something with that response value. Congratulations, you made it till the end. I hope you learned a lot and got some valuable knowledge from this course. If you like the course, please leave a thumbs up on this video. On my channel, I actually cover lots of different DevOps topics like Docker, CI/CD, Terraform, and more. So be sure to check out my tutorials. If you're learning Python to become a DevOps engineer, I actually have a complete DevOps bootcamp with all the technologies you need to learn as a DevOps engineer, which also includes a module for automation with Python, with several cool demo projects to automate some common DevOps tasks like application and server monitoring, cloud automation tasks with AWS, Jenkins, etc. So if you're interested, check out more info in the description. Also happy to connect with you on social media, so I would love to see you there. With that said, thank you for watching and see you in the next video.